I think I lost something. Ah. And then should be attached. Or not? Let's see.
Tra l'altro è anche poco. Dai, che così è il massimo della larghezza, quindi.
Yeah, I think I pulled it loose just now. Okay.
Aspetta, ecco. Vieni, glielo metto io poi. Can you turn?
Ah,
Thanks. Riesci a metterlo. Oh, vai.
Yeah. Hmm?
And then you have the little thingy.
Ok?
Ah, yeah, I think so. Should.
Momento.
Is it okay for you to have the QA at the end for 5 minutes?
Oh, yeah, sure. Yeah.
Okay, so I have those signs there that I'm gonna show when 10 minutes left from the QA. So the first sign will be at 11:15.
Yeah.
And then
Sounds
minus
good.
5 minutes.
Oh. Perfect.
Okay. So your name is David Berenstein?
Yeah, David Bernstein.
That's good.
Okay, perfect.
We still have, I think, 5 minutes to...
Ah, then I'll sit down. Can this be... Does it work now? No, maybe. Hello? Oh. Or did he turn... Ah, yeah. Perfect.
Maybe mute, that you mute button.
Oh. Hello? No.
Can you check a moment?
Hello? Yeah. Ah, okay. Hello? Ah, okay, perfect.
Hello. Hi, everyone. Welcome to the first talk in this room, Spaghetti. So, just to remind everyone, if you want to do the Q&A, we have 5 minutes Q&A at the end, and you can go to the website at the talk. So you can go to the schedule to this talk, and then there is the link to submit the questions. Then I will read it out at the end. So here we have David Berenstein that is going to talk about a very exciting topic, so LLM fine-tuning. He's a DevRel at Argilla, and I think he's going to all talk about the company and the project that he's going to work on. So please welcome, and the stage is yours.
So thank you for the brief introduction. Is the audio okay? More or less? A bit? Okay, better. So thanks for the brief introduction. I'm Dave Berenstein. I'm doing ML and DevRel at Argilla. And for the ones that don't know Argilla is a data collaboration platform that focuses on two main user personas: the domain experts that really know what they're talking about in terms of the NLP models that you would like to train, and the other ones, AI engineers. And the AI engineers normally prepare the data sets in such a way that the domain experts can really provide as efficient feedback as possible. So think about adding vectors, adding metadata, filters, adding initial model suggestions and predictions from like predictive models, but also from LLMs nowadays, so more the generative approach. And today I'm going to talk to you about what a GPU poor company or individual can do in order to actually start fine-tuning your own LLMs and go from GPU poor to data rich, and the data quality practices that we've been preaching at Argilla the last year. So as a smaller individual company, you can actually train your own LLM, and then you can actually do that by, due to the fact that there's more and more consumer GPUs that you can use for fine-tuning methods like Colab and RunPod. For example, the first pre-training phase is normally quite expensive for LLMs, and then you end up spending like 1 million euros, but you can actually skip that pre-training phase and then continue with pre-trained OSS model that's already been published and publicized by companies like Meta and these kind of companies. So there's also more and more of these models publicly available, both for large language models like the 5 models, but also the larger language models going from maybe 7 to 70 billion. On top of that, there's also more and more open source training code available, and normally also all of these training codes get added based on the new research that's being published. For example, the ORPO fine-tuning method that was introduced a while back actually got added to the TRL library from Hugging Face a couple weeks after the release. So that's really cool to see that the open source community and the researchers are contributing to these kind of things quite quickly and iterating to kind of compete with the closed source and closed source companies. And on top of that, there's also the rise of synthetic data. And synthetic data sounds a bit weird because you actually use LLMs to generate data for fine-tuning LLMs, but it's actually something that's works, and that's actually proven to work for several LLMs, and some of the use cases that I'll go over actually go into these kind of things as well. And a cool example is also the open Hermes preference data set that we actually created together with Hugging Face and our research team, where we created this 1 million data point synthetic data set for fine-tuning LLMs as well. And we did that by using the open Hermes model that's like a publicly available LLM. So we've got all the tools. We've got some consumer compute we can get from RunPod, from Colab, and these kind of things. And we've got like the training code, the models, and even synthetic data to really speed up the process from going from ideation to actually fine-tuning a model and having a proper data set. But we actually need high-quality data. So we actually need to improve our data set. And in order to kind of understand what the data is about, I want to kind of go over the 3 training steps for LLM fine-tuning, which are like the pre-training phase. And the pre-training phase is a phase that really focuses on masked language modeling and learning a model, forcing a model to learn how language works. And how language works can be done by forwarding a lot of these data to raw text sources and really focusing on quantity data over quality data. And for this step, normally you require a lot of industry compute in order to get it done. And this is also why it's very difficult to do this phase yourself as an individual company or small company, because it's quite expensive to do that. And this really relies on the masked language modeling approach that we've also seen for the previous generations of transformers, where you kind of enforce a model to learn to fill in masks and learn how languages work and semantic meanings of words in sentences occur. Then the next phase, you actually take this pre-trained model, which is like very expensive, and then you do instruction fine-tuning, which once again relies on masked language modeling, but then you enforce the model to replicate the output behavior based on a chat template. And this chat template is something you can see like the system message, user message, and the assistant message, where you have like a one-turn interaction in the center, on the side, a multi-turn interaction. And this is normally done with structured data sources that really rely on higher quality data instead of huge quantities as in the first phase. And these kind of phases, due to the new fine-tuning techniques that that I mentioned before, can actually be done on consumer compute as well. And then you take that model that you get from the SFT phase and you actually go to the alignment phase, or the RLHF human alignment process. And there you want to align the model that you had from the SFT with human preferences. So really have to add some nuance and some like specific domain nuance that you want within your model. And you do that by having your initial prompt you can see in the center, and then choosing a chosen pair as a generation completion and a rejected response as a generation completion. And also this step focuses on quality over quantity. And once again, these steps can also be done on consumer compute. So initially this was done with RLHF, which everyone probably knows from OpenAI. This is how they trained their first ChatGPT models. But this normally relied on training first a reward model, then a policy model, then a reward model, policy model. So this is quite a complex process because you train two separate models, so you need to iterate every time and look at the data, and takes a lot of compute and a lot of human involvement. But nowadays, most of the models are actually trained with this DPO fine-tuning algorithm, and this DPO fine-tuning algorithm optimizes a single loss function for these things combined. So it really simplifies the process. But yeah, loss functions are a bit complex, and I just came back from holidays, so I didn't want to spend too much time on that. So instead, you can actually focus on this. So you have your initial prompt, and you have two responses, and one response is better than the other. And for the LLM training phases where you really focus on data quality, are the second and the third phase. And that's also achievable on consumer compute. So that's really why we and I will also focus this talk on the last two phases. And we have a cool blog series on alignment methods where we kind of go into all of these different techniques. So PPO, DPO, all of the shebang. And if you want, you can kind of go to the website. It's a collaborative blog series together with Mantis NLP, like a NLP consultancy based in Europe. So we need data quality, and then what? And we actually have 4 use cases that we've seen this for Stanford Alpaca, Databricks Dolly, OpenBNB Ultra Feedback, and eventually also a collaborative approach we launched together with Hugging Face to create our own data set. So the first 3 are about data set cleaning and assessing some errors that they made within their data. And the last one is about a data set that we created together with Hugging Face and our community. So Stanford Alpaca was a data set that was introduced by Stanford Research with 52K SFT examples, so the second phase for the fine-tuning. And this was done with synthetic data. So they were actually using self-instruct, which is a prompt template. So you prompt an LLM together with a template to rewrite, for example, an instruction or a prompt response pair to a better or similar prompt response pair. And this was done using Text DaVinci 3. This is like one of the earlier models from OpenAI that got a lot of hype. And it's also one of the models that was actually a bit toxic and not as good as the models we see nowadays. And this was done based on fine-grained categories like brainstorming or summarization or these kind of things. So they actually took the pre-trained meta model, then applied SFT to it, and then ended up with Alpaca 7B. The problem was that this data set actually contained a lot of references to non-existent content. So for example, you would get a reference to an API method, as you can see here, in the instruction, even though the model doesn't really have access to any API methods. And then the output would be like some gibberish hallucination about an API that doesn't exist for the knowledge model of the model. And there were also a lot more things like toxicity and other things that arose within that model. So the solution can be quite simple. What we did was train a set fit classifier. For the people that don't know set fit, it's a few shots classification method for text classification. And normally you only need like roughly 8 samples per label in order to train a decent model. And it's quite quick to iterate. And we applied 2 labels, clean and dirty. And then we trained the Alpaca garbage collector for multilingual kind of classification for these kind of dirty records or dirty data entries. And you can actually make predictions on all of your data. And then if you go to Argilla or any other nice UI for data cleaning, you can actually kind of filter, for example, on the label that you've applied and kind of skim through all of your dirty records a lot easier than you would do like by hand and looking into them by hand. And another cool thing that was recently released is FastFit. It's kind of a competitor or something built upon SetFit, and I really like the title for the research paper. So if you don't want to do few-shot classification with LLMs, you can actually use FastFit. It normally trains a lot faster than SetFit, but the inference is a bit slower. So easy to iterate, but if you really want to scale, might not be the best approach. The next one is Databricks Dolly, the dataset where the Databricks employees were asked by Databricks to actually create this 15K high-quality SFT dataset, once again for the second phase. And this dataset, 5K employees are all asked to kind of create a prompt and response. So this is once again with the fine-grained categories for example, brainstorming or summarization. And what you can see here is one example of what that might look like. So what the problem was here was that there might have been wrong annotation guidelines or the employees were not motivated for some reason because the length for summarization was often longer than the length for the actual input context that they had to summarize. There were a lot of like context copy-pasting from exactly from Wikipedia, and there were also a lot of references and URLs. So once again, the missing content. So if you were to train a model on data with a lot of these URL brackets, then eventually these URL brackets also come up when the model needs to start generating data. And that's not like the best approach. So as you can see here, that's one of the prime examples for Dolly 2.0 on their website. And as you can see, there's actually a fake URL to a Twitter account that's been generated by Dolly. So what we did was use this text descriptives package, which is an NLP package, apply some basic heuristics and apply some basic assessments on how complicated or what the quality of the text is. And based on that, you can actually kind of filter out like a lot of these length summarization, length input issues, or a lot of these references that you might miss or don't want to have in your text. And based on this, we were actually able to quite easily change 20% of all of the data within the so-called Dolly dataset. And it was quite a nice result. And on top of that, we actually provided some DeepL translations for each one of these entries so that people could actually use it for other languages as well, like for German, English, Spanish, and French as an output. For Databricks Dolly, I can also recommend looking at the text tip package, and they have a cool tutorial to actually filtering corpora, text corpora based on text quality. So there's like these heuristics for the quality assessment for text, and they can kind of grade text on high school level or middle school level or uni level. And yeah, based on that, you can actually already filter out a lot of garbage by having like human involvement, but still doing it in a smart way. Then there's the open BNB ultra feedback dataset that was synthetically generated with 64K prompts, but the open BNB ultra feedback dataset synthetically generated 64K prompts with an instruction pool of prompts from different datasets like UltraChat, GPT, well-known datasets within the LLM fine-tuning space, and then a model pool that was used to create completions for this data. So actually, these completions and prompts were then rated by GPT-4, so using LLMs as judges for quality of annotations and completions based on these instruction following criteria, truthfulness criteria, and also one single overall rating for the prompt and response. But what we actually found when looking at the data was that you would get these gibberish records where you have the prompt, which one is an animal, book, or pen, and the chosen response would then be pen is an animal, book is an animal, and pen is an animal, which is complete gibberish, but it would end up getting a 10 score from apparently the GPT-4 rating. So when looking into the code from OpenBNB and the research behind that, we saw that there was a coding error, leading all of the ones being transformed to a 10, and then you actually trained your model on completely opposite kind of pairs for fine-tuning. So on top of that, there were some incomplete ratings, so not all models responded, and some ties in the data. So then there would be like a preference pair, but then the actual scores would be the same. So it also doesn't really make sense. So what we did was actually use, instead of these overall ratings that Hugging Face and the OpenBNB team used for fine-tuning the Zephyr model, we actually used to have these averaged out ratings for each one of these individual criteria that I just mentioned, like the truthfulness, helpfulness, and these kind of things, and then use that as a rating because they didn't contain a coding error. And what we actually saw was also that these overall rating scores were actually quite well aligned with the averaged out individual rating scores. So there was a lot of correlation. So in terms of costs, whenever you want to do judging, it's probably best to do an overall score to avoid some of the cost. And what we did was train a model. Now the 7B was well received by the community and also the research team of Hugging Face that initially trained the Zephyr model. And the Zephyr model was trained on the dirty ultra feedback data set, and then the 7B model on the clean version. And that's actually also a snippet of how you can use the model. So for the ones that don't know Olama, it's quite a cool package that you can install relatively easily with 3 command lines arguments. You can actually have your own LLM up and running locally. And then the one with Hugging Face, so this one is about synthetic data and human data, a mix of 52K prompts that we sourced from different data sets that were publicized publicly. And the problem that we tried to cover was that there's not much human evaluation in LLM data, and we want to see if humans actually preferred human or synthetic data. So the solution that we came up with was actually hosting Argilla Hugging Face space, Argilla instance on Hugging Face spaces, with and asking the community to rate all of these responses based on the quality that all of these prompts based on the quality of the prompt. So here we really focus on the quality of the prompt instead of the response. And then afterwards we decided to use Mistral Large. So yeah, at the time the state-of-the-art model to create synthetically generated responses for each one of these initial prompts. And then we actually trained the applied spin as a fine-tuning technique, the first reproduction of our research paper, and we actually shared this on GitHub and publicly published a model. So if you want to reproduce and play around with spin, you can actually go to this GitHub repo. It can be found online as well, and then also do that yourself. So what we've been saying is that data quality and human feedback are important for us at Argilla and also for the entire NLP space. But that's not just us, but also some research papers. So for example, the Lima paper that was published half a year ago actually used only 1K examples for doing SFT, and these were like highly curated, manually curated, high quality and diverse examples that were created by the research team behind this paper. It was lacking in math and coding because it can be difficult to actually come up with useful and sensible math and coding questions. And then there's also the data paper, which really focused on finding good data for alignment of models. And this data paper actually combined a more complex pipeline with prompt templating and using LLMs to rewrite in prompts for LLMs. So you would, once again, forward that prompt to a high-quality LLM, rewrite that prompt into a more diverse or more higher quality example, and then use that same LLM to rate the score, and do the same for the responses. So you would kind of evolve the quality, the complexity of the prompt, and then evolve the quality of the response as well. And then do some diversity data filtering based on the scores that the LLM used as a judge. So you would kind of spread out all of your records based on embeddings, and then pick the most representative exemplars for each one of these based on the scores that they got from LLMs. So a more complex pipeline, still a lot of model involvement, but also a lot of human involvement. And the same holds for the AI open foundation models, where they actually set up this pre-training filters for their pre-training data set. And this is like a very complex pipeline that goes from data collection of raw web data, language filtering, perplexity filtering, a lot of these more intuitive heuristics that you can actually apply. And for me, this is also a good example of, once again, human involvement, but also with some smart shortcuts to actually make it work a bit better. And once again, they also use this evil complexity prompt template to kind of improve the prompts using LLMs. So I would say that data quality and human feedback are important. And some pointers to get you started. So quality is better than quantity data, I would say, but how much is enough quantity? For SFT, so the second phase of the fine-tuning, what we've seen work is like roughly 6,000 to 10,000 examples, high quality examples for curated data, where we would kind of reduce the data set size to this amount, and then we would get often a better model that you didn't need to train as long because you have less data, and with better benchmarking results. And the same holds for DPO. But then for DPO, we've seen results even work for 3,000 examples in practice. And for the bare necessities are really getting your hands dirty, looking at the records, and having good annotation guidelines, because otherwise nobody knows what they're actually talking about and how things work. And that's also a thing that we've seen with the Data is Better Together initiative, that we weren't entirely sure what problems might arise when people actually were evaluating records. And it's good to start simple. So you can, for example, add embeddings so that you can do similarity search to find similar records, and apply this classification, for example, with setfit to find some initial assumptions based on some classification that you might do something like text descriptive, topic modeling, and then end complex whenever you actually know what's in your data and what you're talking about, and maybe use LLMs as prompt engineers, so the evil quality and complexity thing that you've seen in the data paper and the AI paper. And then after, you can also use LLMs as judges, but then you can better use an overall rating to do that. And this is a cool generated song about data quality. We'll share it later. Some more cool things. So we've got this cool pipelining framework for synthetic data generation, which is called Distillable. You can actually create reproducible complex pipelines like the data paper or like the AI paper. There's this KTO preference handbook. So KTO is a different fine-tuning approach that relies on just +1, -1, so to say, binary signals instead of comparison data. So that makes it a bit more easier. And not that well researched in practice, so it might be interesting to have a look at that. And there's a multilingual prompt evaluation project that we've launched, and there's still no Italian person that is a language lead. So if anyone wants to get involved, feel free to reach out to me or join the Hugging Face or Chilla Discord. And then there's time for questions, feedback, and these kind of things.
Thank you. So thank you very much. That was very interesting. We have a couple of questions online. So the first one is, you mentioned that URLs can mess up the instruction tuning.
Mm-hmm.
What if you are tuning a model that will be used for RAG? Can it be tuned to use URL from context?
In terms of RAG, you would want the model not to start generating the URLs outside of the context window, so to say. So yes, it's possible, but then you really have to know that these URLs are like the same in your prompt and the response, and that's once again something that you would expect to see in your data. So, for example, the Dolly example that I gave, you would end up with a prompt without any URL, and then you get an URL as output, which is like a fake URL, quite likely. And then for this example, you would have your prompt, then you would have your context window that you provide as a thing for retrieval augmented generation, and then you would eventually get your response where you would expect the URL from the initial input to be the same as the output.
Thank you. And then we have another one. What sources should I check to stay up to date with the latest and best open source LLM models, compared to reading all the models' readmes and Hugging Face?
Yeah, Hugging Face is, I was going to say Hugging Face paper space is nice. LinkedIn, follow the right influencers, I would say. And yeah, things like Hacker News, a lot of these social media websites are nice to follow. And you can also follow us. We try to share everything about LLMs and about cool new models coming out.
Thanks. Any question from the room? Anyone? I have a question maybe for you.
Okay, cool.
So you said that you can use LLM as judge. Did you do any research, or do you know any research on if the LLM can actually match the ratings of a human?
Yeah, I don't know the exact papers, but there has been some research that they align with human judgment. But normally these are just the larger LLMs. So GPT-4, Mistral Large, like the LLMs you also tend to pay for a bit more. And if you want to kind of explore, so to say, how well they align with human judgment, I can recommend just labeling 100 records with a LLM as a judge, and then labeling 100 records with by humans, and then see what the correlation is or any other things that you might want to have a look at.
Thanks. We also have a question. That is good. So why is it so common for model to gaslight on URLs?
To gaslight on URLs?
Yeah.
Can you rephrase gaslighting?
I'm not sure if the person is in the room can explain. I think like makes mistake on URL or try to predict
I think
fake URLs.
Because it's generally trained on a lot of like public data. So data from Reddit, from Wikipedia and these kind of things, and they normally tend to contain URLs. So that is one of the reasons that could be the case.
We have time for one question if anyone has any burning one. Or otherwise, will you be around for question
Yeah,
hours?
I will be around. If someone wants stickers from Argilla at this label or anything, feel free to reach out, or want to chat about LLMs or NLP, feel free to reach out as well.
I want one sticker. So.
Or live.
Thank you very much then. So now there is a 10-minute break, and then we're going to have the other talk.
sembra che... Ma anche meno, sì, che lavoro su boh, no, niente, è nel engineer, quello che vuoi, insomma.
Hey. Hi everyone, I'm sorry to disappoint some of you, but here max 10 people can stand, so please take all the seats available and the rest should leave the room, I'm sorry. They told me that here max for security, max 10 people can stand. So there is one seat here, not sure if there are any seats over there. Of course you can see it in streaming in another room, but yeah, I'm very sorry.
Prova, try, prova.
Non si avvicina a sta cosa, perché secondo me questo è da bambini, stanchetto.
Se no uso il microfono,
Non è possibile.
uso l'altro.
No, dai, vediamo se ci si fa, senza smontarti la testa. Ecco, no, si è smontata adesso.
Ma prendo l'altro.
Prendi quell'altro?
Ma sì.
Ma sì, ma infatti anche io non conosco, guarda. Allora, questo va spento, se no non lo va. Aspetta, se no vanno in botta.
Prova. Prova.
Sorry again, but max 10 people without a seat can stay here standing, so yeah. I invite you either to leave or follow this one on streaming, I'm very sorry. Hello? Yes. Hi, everyone. Welcome to the second talk in the room. So, just a reminder, if you want to ask a question, you have to go on the website on the link of this talk, and then there's going to be a button, ask a question, and then I'm going to read it out at the end. We have 5 minutes for question at the end. We have Stefano Fiorucci, that is developer at Haystack. Haystack is a very cool LLM framework that is open source. I invite everyone to try it. I really like it. So today is going to talk about large language model from dev, from zero to your first LLM application. Thank you for coming. The stage is yours.
Hello. Thank you for having me here. And this is large language model for developers. I am Stefano Fiorucci, software and NLP engineer at DeepSet, where I work on the Haystack framework. Haystack is an open source LLM orchestration framework you can use to build application based on language models. So you can do retrieval augmented generation, question answering, semantic search, and several other use cases. The main building blocks of Haystack, they are components that, following the Unix philosophy, they try to do one thing and do it well. And then you can compose you can combine these components and form pipelines, which are directed graphs, which can also contain loops. But yeah, let's start. Why am I proposing this talk? Since the rise of ChatGPT, we have seen a lot of opportunities for developers, for programmers, but also a lot of hype, of noise. And so the idea of this talk is to discover together the main concept with an hands-on approach, with some code. And yeah, this is a talk for beginners with language models, so for programmers, developers. If you have some experience in this domain, you may not learn much, but I hope you have fun. So this is the idea. Let's start simple. What is a large language model? Generally, with this term, we refer to generative models of the transformers family. You pass in input some text called prompt, and you get some other text, which is statistically plausible, as we will see. But how are they trained? This is a very popular image. It is nice. There are three phases: unsupervised learning, supervised fine-tuning, and then human alignment optimization. Let's see it in a more structured way. This slide refers to OpenAI models, so it's not generic, but it helps us to introduce this topic. So the first step is the pre-training from a massive unlabeled corpus. And this phase is very costly, so only a few companies can afford this phase. And at the end of the pre-training, you get a pre-trained model, which is not usable in real world. Let's see an example. If I ask if I prompt the model with how to make pizza, I can get different responses from a pre-trained model. A recipe, which is good, but I can also get how to make pizza for a family of 6, or how to make pizza, how to make pasta. So a pre-trained model just completes your text in a statistically plausible way. And we need these other two phases. The supervised fine-tuning. In this case, we generally train the model on a collection of instructions or multi-turn interactions. And during this phase, the model learns to follow instructions or to chat. And the last but very important phase is the preference alignment. In this phase, the models learns how to align, how to provide helpful responses. In this slide, it is made with reinforcement learning from human feedback, as in OpenAI models, but there are other other simpler techniques to do that. But at the end of the third phase, you have a model which is usable for real-world applications. So let's start. In this talk, I'm using Haystack. It is a framework that simplifies a bit your life, but does not hide much complexity, so can be good, I think, for educational purposes. Here we are importing a generator, which is the main interface for language models, and then I'm using a generator from OpenAI, which is a proprietary model. You have to pass or set an API key, and you pay per generated tokens in this case. And I ask, where is Florence? And I get a nice and right response. All good, but we are at PyCon. We like open source, so why not switching to open models? And so you can do that easily using this project called Ollama, which is akin to Docker for language models. It is based on another project called Llama CPP, but the idea is that you can use a quantized version of this model, and it can run easily on your machine, even if it is a standard machine. Maybe it will be slow, but it's good. It has an integration with Haystack, so in this code we are importing an Ollama generator, specifying the Mistral model. We could also use the more recent Llama 3, Phi3, which open model you want. And we ask the same question, where is Florence? And we get a nice response. We can also chat with this model through an Ollama chat generator. In this case, this type of generator uses the chat message abstraction with a role, which can be user or assistant, and then a content. And here in this while loop, I'm trying to create a simple program to chat with our model. And here there is the output. I'm asking for indications to plan a trip to Florence, to Italy. So, yeah, it looks nice. Just a quick reminder, there are several efficient ways to create prompts for models. There is this discipline called prompt engineering. So I suggest these two resources, OpenAI Guide and this site Prompting Guide, which provides different prompts for different models. So all good, but why do we need more? There are challenges with language models. Here I'm asking who won the 2024 Italian Super Cup, and both the OpenAI GPT 3.5 Turbo and Mistral, they have not been trained, and they didn't have this knowledge. So their knowledge is not up to date, and also they don't know about your domain, about your specific data, and yeah, this is a first challenge. Let's try to ask about myself. Unfortunately, I'm not so popular, and so both GPT 3.5 Turbo and Mistral makes up a wrong and not factually correct answer, and these people do not exist, they don't have this name. So yeah, this is an example of an hallucination. A way to prevent this, or to make them reason on a knowledge we provide to the models is retrieval augmented generation. In this case, we are simply trying to inject the knowledge, passing some relevant information into the prompt for the model. So we can think of direct prompting, as we have done, as closed book exam. So the LLM knows or makes up a statistically plausible answer, while RAG is like an open book exam. So it can make sense in several situations. Let's see a very naive example. In this case, we are not doing retrieval. We are creating a knowledge base with some information about the Italian Super Cup. Then we introduce a component called prompt builder. In this case, it uses a template, which is a Jinja 2 template, where we are saying, given this document, answer the question, and we put some placeholders for documents and for question. And we create this prompt builder. Then we combine this prompt builder with a generator in an haystack pipeline. So we add these two components, the prompt builder and then the generator, and then we can ask a question: who won the Italian Super Cup in 2024? And in this case, we get the right response. An evolution of this can be WebReg. So the first step is to ask these questions to a search engine like Google and pick the top K results from Google and then inject them into the LLM. But let's see the most common use cases. Usually you have some data stored in a database. You want to, at query time, you want to retrieve the most important information and pass them to the generator to help the language model to provide an answer. So these are the most common databases which are compatible with haystack. There is a great variety. I'm not going into the details of these databases, but each of them has its own retrievers, so the abstraction to look for the right information from them. And let's talk a bit about retrieval. There are two most common techniques. One is keyword-based retrieval, where the BN25 is the most popular technique. Here, the idea is simple. We have a vocabulary with all the words in all the corpus, and each document is composed by a vector of zeros where the word is not present and a number different from 0 where the word is present. And this keyword-based retrieval works well for precise word matching. It's fast, it's quite good, but it can't take semantic meaning into account. But in any case, it is used, and let's see a simple example with haystack. We are using, in this example, the Wave8 database that supports both keyword retrieval and semantic vector retrieval. In this case, we are initializing a document store, which is locally run via Docker, and then we are creating a pipeline with a converter from text to document, then a splitter, which chunks our documents into smaller, more searchable and manageable pieces, and then the writer that writes to the database. And in this case, I'm indexing some textual files about rock music, and this is the indexing part. Then our RAG pipeline with BN25. In this case, the first component is a Wave8 BN25 retriever. Then, as we have seen before, a prompt builder and the generator. And we connect the retriever with the prompt builder and then with the generator. And we ask a question with Samuel Thomas Fender, and we get a response. And this is a query which is appropriate for BN25 because it involves precise names and words. But let's talk about embedding and vector retrieval. First, we have to introduce embedding model, which is another type of language model. These don't produce text, but they produce a vector that represents the semantic meaning of the original text. And yeah, a very common library for producing these embeddings is sentence transformers, which is open source, and currently it is maintained by Hugging Face. But what happens when I try to do embedding or vector retrieval? In this slide, yeah, it is about music. We have 3 documents. 2 are about Green Day and 1 is about Jeff Buckley. And then we have our query, who are Green Day, which is projected in the same vector space. And so at retrieval time, probably the documents that are closer to the query, they are returned. So in this case, probably the documents about Green Day are returned, and this about Jeff Buckley is discarded. Let's see this in action in Haystack. The pipeline is very similar to the previous one, but in this case, we also have a sentence transformers document embedder that enriches the document with its embedding, its vector representation. And now the RAG pipeline with embeddings, which is also very similar to the previous, but in this case the first component is this sentence transformer text embedder that transforms the query into a vector. Then this vector is passed to the retriever, which looks for relevant documents in the database. Documents are passed to the prompt builder and then to the generator. And in this case, I'm asking a somehow hard question. Audioslave was formed by members of 2 bands. Can you name the bands and summarize the Audioslave sound with a short bulleted list? And this is not only focused on precise word matching, but also on meanings. And yeah, I get a very complex and also true response. Yeah. Both BN25 keyword methods and vector embedding methods have its own strengths. So it could make sense to combine them in embedding retrieval, in hybrid retrieval, so use both of them and then join the results. But I'm not going into details. So, yeah, now this first hands-on part, looks good. And now I want to give you some tips about going from demo, simple application like this, to a production setting. I want to give you some suggestions, some hints, some links, not going into details. So, you may ask how to choose a good language model. First, I would like you to read this great blog post on benchmarks by Omar Sanseviero of Hugging Face, which tries to explain the different benchmarks we have, and then some tips to take with a grain of salt. If you want to look for good base models, you should go to Hugging Face OpenLLM leaderboard, but these are models probably to be fine-tuned, not, as we have seen before, we don't use this in real-world applications. For chat models, I suggest this LMC's Chatbot Arena leaderboard, where users blindly judge models, and we have a Nilo score. And for Italian models, yeah, the community is maintaining a great OpenITA LLM leaderboard, which is growing, and I suggest you to check it out. Another important topic is the inference solutions. So where does my model run? And we have seen proprietary models like OpenAI. You call an external API, you pay per tokens. There is the option to have open models on-premise, but we can also use open models hosted by providers. And in this case, if you use a shared hosted model, you pay per token. If you use a privately hosted model, you usually pay per hour. But I want to focus a moment on open models on-premise. So if you want to do local experimentation, if you have GPU, you can probably use Hugging Face transformers on Colab, on Kaggle. If you only have CPU, there is Ollama and also the original project Llama CPP. If you have plenty of GPU resources and you have to serve something that should be fast and efficient in production, there are two main projects. One is VLLM and the other is Hugging Face text generation inference. But in this link, then I'll provide you the link to the slides. But in this link, I'm explaining all these different possibilities. Another topic, very important topic, when you go to production, is evaluation. The evaluation is still a growing topic in this LLM world, but yeah, I give you some concepts. You can think of evaluating single components, such as the retriever, so you evaluate if the right information is retrieved. You can also evaluate the end-to-end pipeline, so if the right response is generated. And there are statistical and model-based methods. The statistical ones, you have to provide labeled data. Model-based, you use another model to evaluate. So you don't need labeled data in this case. And I suggest to look at the Haystack evaluation docs. And also, there are also other frameworks to do that, open source frameworks, and Haystack integrates with DeepEval and Ragas, which are focused only on evaluation. Obviously, another topic is deployment of your program, let's say, of your application. Here I'm talking particularly about Haystack. Haystack pipelines can be serialized to YAML, and they can be served using this little project called AUX. In this case, you run AUX run with your pipelines directory, and your pipelines are served as fast API endpoints. So you can call them, and you can create also a web application based on them. AUX is based on fast API, and for Haystack you can also find deployment guides for Docker and Kubernetes. What you can build with language models goes beyond RAG. And I want to talk just for a moment about recent projects done with Haystack. In this multilingual RAG from a podcast, I was interviewed in an Italian podcast, but I wanted people to ask questions about this interview in English, and so I built a simple pipeline with a transcriber, with a multilingual embedding model, and then a multilingual generator. And yeah, the nice thing is that in the end, yeah, you can ask these questions and get responses in English, but the original text is never explicitly translated. You can find this project and others in the Haystack cookbook, which is a repository. Another interesting application, I think, is information extraction. You probably know classic ways to do that, name identity recognition, classification. The nice thing about using a language model for this is that you can dynamically define the structure you want to be extracted. For example, in this case, I want people, companies, but I also want a summary of a certain article. I want to know if it talks about animals, if it talks about AI, and I can change this schema and apply it right away. And it works quite well. Yeah, last week I shared this demo. This is nice, but not very complicated. The idea is you pass an URL to a language model and you generate a multiple choice quiz you can play with, but you can also let the language model play with it in a closed book fashion or accessing to web. So the language model never sees the original source, but can find other related information. So there's a lot of things that you can try and you can build with the language models. There is much more. Yeah, some of these features in this slide, they are simple or classic, for example, file conversion, but as you may imagine, yeah, extracting text from different types of documents in the right way is very important to make this language model reason on these sources. There is observability of this application once they are deployed, so logging, monitoring, tracing. Haystack has some stuff around observability, even if I'm not an expert. Then about capabilities of language models, probably one of the most interesting ones is function calling, so the ability of these models to provide a structured response, to prepare a call for a function, not invoke the function, but yeah, this makes it easier to integrate the language models in deterministic classic applications. And then there is a whole new area of agents, and this is the topic probably for another talk, but I want to give you a last word about this recent blog post by Berkeley AI Research, and they are seeing this, and I agree with this opinion, they are seeing this shift from single models that can do something to compound AI systems. So in this case, the model is just a component of your system, which is more complex. And so you can realize applications that are a mix of deterministic and statistical components. And while language models could be also, or maybe in the future, they will be commoditized, we can see a lot of value in integrating them in application. And yeah, thank you for your attention. And
Thank you.
you can find also the slides on GitHub. Check out Haystack. Yeah, send me a connection request on LinkedIn if you want. And probably, yeah, I was too fast.
No, we have a lot of interesting questions here, so just to remind everyone, you can go online and ask your question. I will read it out for you. You can also upvote the existing questions. So we can start with the first one. How can we judge the answer given by the RAG? Do we need a human to classify them as correct, not correct? Are there solutions to do it automatically?
Yeah, this is about evaluation of RAG systems, and I provided some links before. The idea is that, yeah, you can do it as a human, provide labeled data or label them. The previous talk was by David, who works at Argilla, and Argilla is a data annotation platform which also helps with this. But another idea is also to use powerful language models to judge the responses. So there are many metrics with names that are fastly evolving, but faithfulness, correctness. So you ask to the language model with a specific prompt to evaluate the response. And I think that previously we were mostly using GPT-4, which is a powerful model to do that. But in the last months and weeks, there are also open source alternatives which are trained to judge what other models do. So it's not mandatory to use GPT-4. And yeah.
Thank you. Second question, how does Haystack differ from something like LangChain?
No, the value proposition, I think it is the same. Orchestration frameworks like LangChain, Llama Index, and Haystack, they are in the same pool, and they try to make it your life easier. Yeah, probably with Haystack is designed with some software design principles in mind. So we want to make your life easier without hiding too much stuff. So I haven't shown this to you, but creating a custom component or customizing an application with Haystack, usually it is easy and it is taught in this way. So yeah, it is the same pool, but we do different software design choices, and we hope that you can find it easier to customize. We are also committed to not release, to not do not announced breaking releases. And we are committed to software principles. Yeah, I would say that.
Thank you. Next question. Why do models provide the wrong answer, hallucinate, instead of saying they don't know?
This is, the reason is that they are trained the original training teach them to provide a statistical plausible answer. So they generate text, and we like them also for this reason. You can use for creative things. And so probably with the current architecture and training we can't avoid hallucination. What we are doing is passing the right information, then you can evaluate is the given response is grounded with the information, but this statistical nature of creating a plausible text, yeah, does not go away, I think. Yeah.
Thank you. We still have a few questions. We have 10 minutes left, so keep the question coming. What are good models to start for a beginner?
It depends. Yeah, also, if you want to start to build something, as I've shown, you can start with OpenAI models. If you want to pay, it's the easiest thing, but you can also switch to Ollama, and then so in your local machine you can run these models. And I have shown I was using Mistral, which is a 7 billion parameters, so it can run in your local machine in a normal laptop. You can also use Llama 3 8 billion parameters. Yeah, there are, I think that to start in your local machine, you should look for 7, 8 billion parameters models or less. Yeah, and so in these days, probably I would use Llama 3, but yeah.
Thanks. So next question is about the documents. So what are the formats of the given documents? Could they be search engine results about my topic?
Yeah, they can. As I was showing in this WebRag application, the first component, which does search on Google, it produces documents. Documents in Haystack, documents are simple, yeah, a very simple abstraction with a content, and the content contains text. But yeah, the document format also has metadata, so you can write JSON things. Yeah, you can put whatever contains text. Yeah. I also know of a person who played with data frames, but this person is him. Yeah, you can push data frames to documents. Yeah.
The question is gonna be about what are your thoughts on AI search engines such as Perplexity or Arc Search?
I'm not an expert user, so I don't have strong opinions about them. Yeah, probably they work, and probably for this WebRag application you can just ask Perplexity. For when you want this, when you want an application that can reason on your data, yeah, you have to do something different. Yeah.
Thank you. I don't have any more questions online. Anyone from the audience wants to ask a question? Sorry. I need to come with the microphone.
What problem can you find when you are going to production?
No, you can probably find several different types of problems, but yeah, probably evaluation is important. Also, maybe you want also in the future to replace your model with a new model, and evaluation is crucial, but also this part about observability I haven't talked about this. I'm not an expert, but we integrate with some observability, some open source observability solution, and also new open source packages for LLM observability. So this can help monitoring what is happening. And also, I haven't talked about all the risks related to security, so prompt injection and other stuff. But you can find more information on Haystack. But yeah, I think these are important topics. Yeah, and also yeah, real world enterprise obviously care also about these risks, also about trust. Yeah.
Do you think that it's an easy tool to start a new project? For example, now you have some log files to parse, and you want to get some patterns, some information out from those log files. Is it easy to use this tool for this kind of new project?
What do you want precisely to do with these logs?
I want to train a new model using some log files. They have timestamps for information like, for example, pointer data, which is changing every time, of course, but you want to catch something.
And what is the
goal is to catch if some test cases are failing, for example, and there are failures that you are not able to recognize normally. Then maybe there's something hidden.
Ah, okay. No, currently Haystack is not focused on the training part. So if this involves if this involves training, I would suggest other tools. Yeah, there are many. I don't know. For example, I don't know if for your specific problem you need language, or you can reason on more structured numerical data. I don't know, but there are several other options. Currently, Haystack is just focusing on building with models you trained in other platforms. Yeah, also for language models training, there are many more good projects. Yes, so sorry.
I have another question online. How does Haystack play along with Kubernetes?
Yeah, we have these deployment guides, which one of these deployment guide is about Kubernetes. I think there is also another guide about OpenShift deployment. Not an expert, but yeah, these deployment guides have been written by my colleague, who is strong in DevOps. So I recommend you to read them. Yeah.
Any other last question? We have time maybe for one quick one. Okay, so thank you very much. Test, test. Yeah. Hello, everyone. Welcome to the third talk of this morning in this room. So just a reminder, if you go on the website, the schedule, and you go to the link of this talk, there is a button to ask question. I'm gonna then read the question. There is also an option to upvote. If you see an interesting question, it's gonna be read first. So here we have Kat and Chris that are gonna talk about a very exciting topic, so machine learning miniaturization. So AI on a budget, methods for machine learning miniaturization. That is, the stage is yours.
Thank you, Eduardo, for that nice introduction. This is Chris.
And this is my colleague, Kat. We are both freelance data scientists. Kat is based in Berlin, and I'm based in Hamburg.
Whew. It's been an eventful couple of years, hasn't it? It seems like nearly every week news is coming out about some new super capable large language model, some super impressive image generator, or a fantastic image video understanding system. There's been lots of speculation about these big corporations that release these models nowadays. What kind of resources do they actually put in? For example, I've read that for building GPT-4, OpenAI actually invested something like tens of millions, up to $80 million is a figure I've read. Sounds completely incredible. But they must be using thousands, perhaps tens of thousands of GPUs and training on these massive private data sets that we don't really know much about. It's easy to start feeling a little bit left behind. Is it really so that scaling is all you need? Do you just need to put on resources upon resources to get ever more capable models? And if that's the case, where does that leave us? The small teams, the open source developers, the PhD students, the GPU poor. We are not going to be the ones who set sail into the unknown with our armada of GPUs in search, perhaps, of a new frontier of foundation models. No, this is us in the tiny boat, a small team, a handful of GPUs, perhaps not even that, using mostly open data or small data sets that we've collected for ourselves. But we don't need resources to be clever. We just need to know about a couple of methods that can help us take an existing large model that somebody else has trained and make it work for us. But we gotta make sure that we don't row in the wrong direction, because over there'll be monsters. Models that we have put in our scarce resources with nothing much to show for. And that is why today we want to talk to you about 3 proven micro-budget methods for adapting an existing model to your needs. The first one will be transfer learning, an oldie but goldie, where you want to take an existing model trained on some task and make it work for a different task. The other 2, distillation and quantization, are all about taking a large model and turning it into something smaller, more manageable. All of these methods are micro-budget friendly, meaning they're suitable for small teams, at most a few GPUs with small data sets.
And to make it all more hands-on than a simple talk, we have prepared for you a companion repo on GitHub. And this repo contains, for each of the methods that we are going to talk about, one example workflow, one example notebook that's easily going to run on a laptop like this. So we invite you to clone this repository, run this later after the talk, and see for yourself how well the methods are working. So method number 1, micro-budget method number 1, transfer learning. This is going to be very familiar for many of you, I guess, but still, this is such an elegant and essential method that we want to start the talk off with this. In our example repo, we find the following computer vision task. We have this interesting botanical data set of flower images, 8,000 images of the flowers. They belong to 102 different species, and our task is to build an automatic classifier that can classify each of the image into the respective species. So it's 400 megabytes of image data. That's not massive, but if you think about it, if you want to train and develop a model from scratch, that may be a strain on our micro budget. First of all, you have to decide on the right architecture. Maybe you have to experiment with the architecture, and also you have to invest a little bit of compute time to train this model from scratch. So can we do more with less? Can't we take one of those well-working and proven image classifiers that are out there, for example, the MobileNet V2. It's an elaborate architecture, a deep convolutional neural network of 53 layers, about 3.5 million parameters, and it has been shown to have good accuracy on the famous ImageNet dataset. ImageNet is well known as a benchmark, 1.4 million images belonging to 1,000 different classes of objects, and this is truly massive. It's 150 gigabytes of images. So here's a proven image classifier, but it's for the wrong task. And here comes the basic idea of transfer learning. We have this model pre-trained for task A, usually on a very large data set that is beyond our micro budget, and we want to reuse a part of it, partially retrain the model for a new task, task B, usually on a very much smaller data set with much less compute resources, and we get out a model specialized for task B. So how do we go about this technically, and why does it actually work? What is the intuition? The intuition here is that the convolutional part, the deep convolutional layers of the pre-trained network, they contain generalized knowledge about how to process images. For example, detect edges, objects, object composition, and so on. That's our hypothesis here. This knowledge, this capability is not specific to ImageNet. So we can just take this and reuse it. So we take these first convolutional layers, including the weights, we freeze it, we take off the ImageNet specific classification part and attach a new classification part for our flower classification. And we only retrain this specific classification reusing the weights of the convolutional layers. And we're not going to show you a lot of code on the slides. You have that in the notebooks. But these few lines of code show that there's great library support with libraries like Keras for transfer learning. Not only do they let you download the MobileNet V2 with the ImageNet weights, but they also expect you to only download the top. That's the include top equals false argument. Then you plug it together with a custom classification part, And as you can try for yourself, with only a few minutes of training on a laptop like this, we get a decent flower classifier with minimal engineering. So transfer learning at a glance. We're adapting a model to a different task. The way we do it means that the model size stays roughly the same, also the inference cost stays roughly the same, but we can get away with much, much less training data and training cost usually. And as you will see when you look at the notebook and run it by yourself, the development effort is really small due to good library support, so it's a pretty simple technique to try.
The second method we want to introduce you to is distillation. Let's assume we have some large model that somebody else has trained, and it's doing its job really well. But being such a large model, it's a bit of a pain to deal with. Like for inference in deployment, we need quite a bunch of resources. And honestly, we'd kind of prefer something smaller, a bit more flexible, but that still needs to get the job done. And this is where the fusion comes in. So we're taking a large model trained by somebody else, and we're using that model to teach a smaller model. And easiest to see how that works is by looking at an example. Perhaps many of you have heard of the OpenAI Whisper model. It's an audio transcription model. So basically, you put in an audio file and it returns to you the transcript of the words being spoken in that audio. It's a fairly large model at 1.55 billion parameters. And it was trained on nearly 700,000 hours of audio and transcript. Not too long ago, Hugging Face came out with a model called Distill Whisper, which is, well, a distillation of Whisper. So let's look at how they trained their Distill Whisper. They started, of course, with the original Whisper model from OpenAI and put through it some audio file and got returned, as we've seen earlier, the transcription. They then feed that exact same audio file also into the small model, together with that transcription, and use that to train the small model, which basically, if you think about it, means we don't need annotated training data. We don't need to have the original transcript of the audio. We can make use of the large Whisper model to generate those transcripts for us. This is huge. It's much easier to find a bunch of audio clips than find a bunch of audio clips that also have been transcribed. It turns out that actually Hugging Face is tying these models even further together. So in addition to feeding the transcribed audio, they also feed in for every time step of the audio file the prediction for the next word that is probably going to come up. And we'll see in a second why they're doing that. We've already seen one of the big benefits of distillation. That is, we need much less, perhaps even no, annotated training data. But there is a second aspect that I would like to talk to you about. There's a good chance that if we had the original 700,000 hours of audio and transcripts and used those to train our small model, we still wouldn't have achieved as good a model as we can through distillation. And that seems really, really unintuitive, doesn't it? So let's look into it. Why could that be happening? If we take a step back, we kind of have to admit that the way we're training our models is quite harsh. Let's assume we have some image classifier and we feed it an image of a large ship. We want the answer to be ship, which certainly shouldn't be football, but it also shouldn't be boat. We punish every mistake. But if we look at the right-hand side on those predictions, they don't actually look that bad. In fact, they might even be a sign that the model is starting to generalize a little bit. It does make sense to mismatch a little bit between a ship and a boat. It seems maybe the model has started to get a general idea of things that float on water. And it seems really, really counterproductive to punish this. So it turns out that large language models can learn despite this harshness that we are putting them through. But small models, they sometimes struggle. Why that is the case, we don't really know yet. This is an area of active research, and I just hope that I can convey to you some intuition of what is going on here. So, what distillation then does, it does create a much more friendly learning environment in which even small models can thrive. Instead of feeding those hard labels, we feed in the soft predictions in a way already interpreted for us by the large model. And this way, we can train the small model much better than if we trained it from scratch with the original hard labels. In this way, the Still Whisper ends up being 6 times faster, 50 times smaller, and with nearly exactly the same performance as the original model, at least for English, at a cost of only 2% of the original training data. And I think this is completely amazing. In our companion repo, you will find a notebook about Whisper and the Still Whisper. And you have a chance to transcribe, to use Whisper and the Still Whisper to transcribe here and see for yourself how well they are working. To summarize, we can distill a large model into a much smaller model with nearly the same performance and only a fraction of the original training data. But I must warn you, distillation is newer. Library support is not as good as transfer learning, so getting up and running with it will be more complex compared to transfer learning.
Micro-budget method number 3, quantization. That's a hot topic right now because it's one of the factors driving the, I should say, explosion of open LLMs that you can run on your local machine with modest hardware, but a bit more on this later. What's the basic question we're asking here? The question is, do we really need the full precision of floating point numbers to represent the knowledge that's in the model, to represent the model's weight? If we could manage to represent the same knowledge with, for example, 8-bit integers, we would have a 4 times smaller model file, 4 times smaller model footprint in the memory. And also, if we can do the compute, the inference in integer, 8-bit integer, then we can have a 2 to 4 times faster inference. So it would be great if we could manage that. How can we attack this problem? We have the original distribution of weights, unquantized, in float 32. And we want to map them to 8-bit integers. So 256 values from -127 to 127. And this can be done by fitting 2 parameters, a scale factor, and a zero shift. Scalar basically determining the 0 point of the new distribution. And then the quantized weights result by a simple formula in the top right from the original weights. So in practice, what would we do? We would go through each component, each layer, channel, and so on, and analyze the weight distribution to calculate the parameters S and Z. Then we apply the quantization formula, and we store only the quantized weights. So float 32, int 8, 4 times smaller weights. Great, we have a smaller model file and a smaller footprint in memory. But we haven't taken care yet of computation. What happens during computation? We also want to perform the inference in the lower precision data type. We can apply basically the same strategy to the activations of the network. However, for that, we need to determine the distribution of activations, and we do that by running the forward pass of the network with a few samples. Then the principle is basically the same. We calculate the two parameters and we map the activations also to the reduced precision space. And that gives us, if we can do only integer multiplication instead of floating point multiplication, 2 to 4 times faster inference. Can we drive this even further? So 8 bits is not small enough. Can we go for 6-bit, 4-bit, or even 2-bit quantization? Yes, those are all common. Those are being done. And you might ask, what are the capabilities that we are sacrificing? If we are so strongly compressing a model, we must lose something. And that's true, we have to expect some capability loss. It's hard to predict upfront. The models vary in their sensitivity to quantization, so you need to evaluate the capability loss experimentally. Question for the micro budget, do we have to do all the evaluation by ourselves? Well, luckily, quantized models are being provided to us in many cases, and the model card also recommends a particular quantized version that works well and maybe warns you if the capability loss is so large. So by radically quantizing, we can make the model file here up to 16 times smaller for 2-bit quantization. But we are going to pay for that probably with some capability loss. In our companion repo, you are going to find a notebook that shows you, first of all, how to run a quote-unquote large language model on your local machine. A laptop like this one should be enough, with a great tool called Ollama. And we also show you how to get different levels of quantization for a particular model, host all of them with Ollama. It's an easy workflow how to integrate it into Ollama. And then you can test and observe the capability loss, the development of the capabilities. And since we're in the impressive city of Florence, we're asking the model to recommend us an itinerary for sightseeing. I invite you to try it out, but maybe fact check the 2-bit model before you go out and look for the Leaning Dome of Florence. So as I said, the OpenLLM ecosystem thrives on quantization. It enables us in the first place to run even medium-sized models on modern hardware. Takes 15 billion parameters in 9 gigabytes of RAM. And it also makes the distribution of these large files much easier. So as a consequence, many of the models that the Ollama catalog is hosting, they're quantized by default. I've often seen 4-bit quantization as the default. So at a glance, we are getting a model from quantization that's potentially as capable as the original, depending on how much we quantize. We can make it much smaller while sacrificing very little of the capability. So we also speed up the inference. And the process of quantization, for that you need a lot less training data and training resources to perform that if you want to perform it yourself. Applying these models, as you will see from our notebook, is quite easy. Ollama helps us here. I'm joining the crowd of people praising Ollama. It's a great tool for getting started with your local open LLMs. So that's the end of our presentation. We'll leave you with this overview slide and would love to start discussion and taking questions here. Thank you.
Thank you very much for the very insightful presentation. Are there any questions in the room?
When you use smaller quantization, you are using data types which are not really able to be handled by the CPUs or GPUs normally. So you need packing, unpacking, data shifting, something like that. So you are wasting a lot of resources and computational power for that. How are these is going to be useful for people which are using those local models, because you want to execute those models on your laptop, your PC. And this requires much larger computational power for handling this data format which are not native.
Okay, yes, you're right. If you don't have specialized hardware, you will, well, at the very least, benefit from the model size being smaller. But it might be that whatever framework you're using actually unpacks this back into the original data type, and then you haven't really won anything in terms of computation. What we are seeing is actually people developing quantization schemes as well as hardware in combination. And if it's not already the case, I expect these kind of things to also be in mobile phones and computers at some point, so that you can directly benefit from the quantization also on a hardware level.
I saw another question.
When you were talking about the quantization, especially the 2-bit quantization, I was thinking about, well, it is real faster, but probably the output is not the same as the original. So are there any studies about like an ensemble method of quantization with 2-bit? I mean, it's real faster. Is it possible to mix some of these 2-bit quantization together to have a real good output and like stay always faster than the original model?
That's an interesting thought. I don't think I've seen any research towards that. I don't know if you've seen anything, but I mean, assembling multiple smaller models to, in combination, perform better than each of them individually. I mean, that's a pretty standard strategy. So I'd expect that this actually gives you some benefit. Yes.
Hi. Again, about quantization, I imagine there are a lot of weights in the model which are statistically not very significant. So I was wondering if it is possible to perform like a statistical analysis of activation to decide not to quantize all the weights, but just the least significant ones.
Yes, completely correct thought. There's a field of activation-aware quantization. We just kept it simple for this talk and for the examples and didn't dive into that. But definitely there's active research and also practice in that direction.
I have a question online. Is it feasible to train in integer domain?
So we've introduced post-activation, post-training quantization. There is also quantization-aware training, but then you don't actually train in the integer domain. Rather, you keep an integer as well as an original precision copy of the weights. The reason for that is the gradients that we are applying, they are quite small. They're too small and too fine-grained to be captured by the integer. So basically, we run the forward pass both with the integer and with the full precision weights. We calculate the gradients and then apply these gradients to the full precision weights, and then do the quantization again to get to integer weights. It's probably going to be better than post-training quantization because you're already kind of pushing the model into expressing itself, if I may, with these 255 or even less values, but directly training in integer, no.
Thank you. Any other question?
About distillation, I saw that example that you showed about the model that has been trained upon data upon a bigger model. Wouldn't that be risky? I think it just inherits the weakness of the first model and its mistakes. It doesn't learn from mistakes, but it learns mistakes to reproduce that.
I mean, you're not going to be ending up with a model that is more performant than the original model. That's not possible. So whatever the original model is doing wrong, the new model is likely also going to be doing wrong. So yes, pick take a good starting point before you do distillation. Make sure that the model that you're distilling is actually doing what you need it to do.
So to clarify, in the best case, you preserve the capabilities of the original model, but you can make it much, much smaller. That's the micro-budget approach here.
Thank you. We have time for a very quick last question, if you have one.
Can you combine distillation and quantization?
I kind of was waiting for that question. I'm sure people are looking at that, yes. So for me, I think Chris disagrees a little bit. Both of these methods, they feel of kind of, we have these large models and we perhaps needed to have them that large to get them to train. But whatever they have, what kind of knowledge they have can be condensed. Now, if we do two types of condensations, maybe we're going too far. So probably you need to find some good equilibrium there.
I think we have also time for yours.
Can you do multiple distillations? I mean, I take a larger model, I distill into a still large model, and I do subsequently distillations until I reach a much smaller model. Does it make sense, or one distillation is enough?
I've seen some work on iterative distillation, indeed, yes. I don't have the stats right now, how much that adds.
Okay, thanks.
So thank you very much for your talk. That was very, very good.
Thank you all.
it working? Okay, thank you everyone for attending this session. So first, disclaimer, to ask questions on the Slido and to upload the existing questions there. So we're going to do the QA session. We are having here Eric Vrede. He is a software engineer and GraphQL expert that enjoys building full-stack GraphQL solutions. He's a member of GraphQL Python maintainer team and a core dev at Strawberry GraphQL. You're going to hear a story about how they managed to make it 7 times better.
All right, thanks, Nicolas. All right, yeah, as he said, I'm going to share with you the story of how we implemented some Rust in our Strawberry code base, and hopefully you guys get some takeaways for your own Rust project, your own endeavors. Okay, yeah, much better. And yeah, first let me say a few things about Strawberry. Strawberry is a GraphQL framework, and it was created by Patrick Aminio. And the special thing about Strawberry is that it follows a code-first approach, which is inspired by data classes. So basically, when you have a GraphQL schema, you define it like in a very Pythonic way with data classes, and it feels very fluent and idiomatic to work on that. And Strawberry offers a range of integrations, for example, for Django, SQL Alchemy, Pydantic, and many more. So before we get deep into the topic, let me do a quick survey. Who of you here has used GraphQL before? All right, and who of you has implemented something on a backend side in a GraphQL server? Just some resolvers, has worked on a GraphQL schema? Okay, not so many. So let me give you a quick refresher. In general, what's GraphQL? It's a query language for APIs, very simplified explanation. And the most common use case is when you have a front end and a back end, and you want to fetch data from the back end in a customized way. So in GraphQL, the special thing is that you can have a front-end client tell the back-end what data they want, and the back-end will resolve it accordingly. And I'm going to show you a quick example for that. I've built a GraphQL schema for the PyCon conference. On the left here, you can see a couple of types. For example, the type conference, the type talk, and the type FAQ. And in GraphQL, with all of these types, you build up a graph. And this graph basically represents the data you can fetch from the API. And each type can have specific fields. For example, either the ID and the name, which are scalars, so to say primitive types, or they can link to other types. And in this example, you might have a conference which has a list of talks or a list of FAQs, and then in turn the talk which has a list of users as a speaker field. So you have a bunch of types and fields. And now when you make a request to your server, you basically formulate a query. In this case, I've written a little conference query. And over here you can see I request a conference with the ID PyCon Italy 2024. And now in GraphQL, I can just choose which kind of information I want. So in this case, I want the name field, I want the description field, but I'm not interested about the ID field of the conference. And the same goes for the talks. I'm not interested about the description, I just want to know the title and the speaker. And the GraphQL server will then go ahead and resolve me exactly what I want. So I'll get a custom-tailored response, mostly in JSON format, that fits exactly my data needs. And the nice thing about that is that it prevents a lot of overfetching and underfetching that you know from typical REST APIs. It's the common first point on GraphQL, like the common argument on why to use GraphQL. But there's many more arguments, and if you're very interested about GraphQL, you can stay for the next talk by Thiago, and he's going to tell you how to implement GraphQL APIs in detail with Strawberry. But to give you a quick overview of GraphQL in Python, there's 4 big libraries you can use. It's Strawberry, Graphene, Ariadne, and Tardiflat. And Strawberry, Graphene, and Ariadne all use a shared core, which is GraphQL core. It's the reference implementation of the GraphQL specification in Python, and it's maintained by Christoph. So shout out to him, because he keeps maintaining it, keeps updating it to all the newest features. It's great to have that. And then we have Tardiflat, which is another GraphQL framework, and it has its own execution engine, but it uses libGraphQL parser, which is a C library for GraphQL parsing in the background. Just a few more things about Strawberry. This is how you would implement a GraphQL schema in Strawberry. First of all, you have the conference class, which represents our conference type. Before, you can see all of the fields. They are written like you would write a data class with the type annotation, and Strawberry will go ahead and automatically build a schema for you from that. And if you can see down here in the query type, we've defined a resolver for the conference to resolve the conference, if you remember our sample query. And you can basically define custom resolvers for whatever data needs you have. For example, if you need to load data from a database, an external data source, and they can be sync or async. So now that you know a bit about the basics of GraphQL, let's have a close look at request execution in GraphQL servers, because that's actually where we want to optimize performance. So we kind of look at the GraphQL request lifecycle starting from the schema initialization. Basically, you define your types in Strawberry, and Strawberry builds a GraphQL core schema for you where you can execute requests against. And then when a specific request comes in, maybe through a fast API web view, Strawberry will handle that and extract the operation, the variables, and everything you need to execute the request. And it will pass it on to GraphQL core, which will then take this query string over here, and it will parse the string. And during parsing, the query string is transformed into a machine-readable format, so the abstract syntax tree. And I'm going to show you in detail what happens here in just a second. I'm going to zoom that in. And you can see the abstract syntax tree really represents the format of our query. We have a document node on the top, and then an operation definition. And there's a lot of things that are happening. So you can see the document node is basically the entire GraphQL query document. And then each element of this query string has its own node in the abstract syntax tree. For example, we have the operation definition. And the operation definition contains what kind of operation I'm running against the server. For example, a query as opposed to a mutation or a subscription. And same for arguments. We have argument nodes, or other fields. We have field nodes down here. And this basically is a representation that allows the GraphQL execution engine to resolve exactly the fields that you need and to know what kind of data you need to have. So in the next step, you want to validate that AST and that query to see if it's valid, if it works with the GraphQL schema you've defined. So there's a long list of validation rules. One of the easiest is, do all fields exist? Are all of the arguments the user's passed valid? Is every variable used? Or are all of the leaf nodes that you define in your syntax tree scalars? So these are all the rules that are processed on the abstract syntax tree, and there's a lot more rules. They're all defined in the GraphQL specification. So if you're interested, you can check that out. And every GraphQL server follows these same validation rules, so it's all a standardized implementation, and you can expect every GraphQL schema, at least with regard to validation, to behave the same. And that's basically the contract of GraphQL. So after that, we can finally execute the request. And for that, we again use the AST to collect all of the fields that were requested. We then call the resolvers for each of the fields, for example, the conference resolver I've just showed you. And then in the end, we validate, is the response really of the shape that we expect it to be? So we do type coercion and a lot more steps just to ensure that the user gets exactly what they requested in the first place. And once that's done, we get a nice response. You saw the response already. And now in Strawberry, we can prepare that response and send it back to the user, for example, in one of the many web views like Fast API, Flask, and so on. So now that we know how a bit of a GraphQL life cycle works, are we ready to just rewrite everything in Rust? Just go ahead. I mean, that was the topic of the talk. Well, you guessed it if I asked it like that. No, we aren't. And it's not that easy because there's a couple of reasons for that. And the first one is performance reasons, actually. Rust is supposed to give you performance. But if you interface a lot between Python and Rust, you can introduce additional overhead. If you call a lot of Python functions from Rust, it's actually slower than calling the Python functions themselves from pure Python. And this is even worse when you're using async I/O. And as you've seen, data fetching, you can do a lot of data fetching in GraphQL when you're doing an async call to a database. Pyo3 async I/O, so the Rust-based async I/O support for Python is actually slower than async I/O itself in Python. So you don't want to switch between that too much. Another big reason we can't just rewrite everything in Rust is because we're an open source project. So of course we have certain kind of time constraints, and we have a limited scope on that, and we also need to prioritize other features. And the last important point is like a best practice advice. Whenever you do a full rewrite, if it's an entirely new project, that's nice, but if you want to improve your existing project, you actually want to track what does the rewrite do, what is the impact, what are the features, and what are the performance impacts you have. And it's easier to do that when you do that incrementally and check, are all my tests still passing when I replace the module, and so on. So for our case, with all these constraints, let's have a look at what we can improve. And let's look at the request lifecycle again. And first of all, we cannot really improve initializing the schema, because that's really out of scope. We really want to improve request performance right now. Handling the request is also very specific to the web server implementation. You could switch to something like Granian for even better performance in your web frameworks. So that's really not up to us either. But what we can really influence is parsing, validation, and execution performance. Execution performance is really hard to achieve because of the many async IO resolvers and the callbacks required to run all the resolvers in Python. But parsing and validation are very encapsulated. It's a fixed set of rules. It's mostly CPU bound. And we can see in small GraphQL requests, they actually take a lot of time in Python. So this is a very small GraphQL query. And on the flame graph here, you can see that parsing and validation take up almost 80% of the entire request time. And they're all CPU bound tasks. So this is a perfect candidate for moving into Rust, for processing in Rust. And I'm going to show you how we did that. So basically, this is our starting point. We have Strawberry, which interfaces with GraphQL core. And based on that, we implemented a new library called Rustberry. Very creative name, I know. But that actually handles the data mapping between Python and Rust. And you can see the shared interface between Rustberry, GraphQL core, and Strawberry is the abstract syntax tree I introduced you to. And this is basically what we share between all of these components to let them know what fields are requested, what to validate, and so on. And in Rust, we also relied on existing libraries, relied on existing standards, and we selected Apollo Rust for the Rust tooling library part of our execution engine. Because it's already existing, it's available, it supports all of the validation rules, and has a very fast parser. And next step to look at when we do such an implementation effort is to see how the abstract syntax tree is actually implemented in GraphQL core. Because with this project, we have a lot of requirements with compatibility. Because when we pass an abstract syntax tree from Strawberry into GraphQL core for execution, it needs to be compatible with GraphQL core. And GraphQL core needs to be able to understand it, even if it came from Rustberry. So we need to find a compatible format. And for that, let's have a look at the structure of an abstract syntax tree in GraphQL core. And you can see it's class-based, it's very hierarchical. So you have a node as the base class, and then you have other classes expanding from that, like the selection node, or in this case, a field node, which is a selection node. If you remember from my graphic, a field node represents that a specific field is selected in a query at a specific type. And this structure needs to be respected by our library Rustberry in order to interface properly with GraphQL core. We have some other data requirements. In GraphQL core, there are a lot of instance checks. So if we generate an AST in Rust, we need that to pass the instance checks. But on the other hand, we do not require all of the fields on the syntax tree for execution. So maybe we can save some fields and save some performance by not initializing them. And in general, there's 3 big ways to build Python types in Rust. I'm going to show you all 3 here, and then we're going to compare them. The simplest way is just to transfer a string or a JSON object or a dictionary. So over here is a JSON serialized version of the field node I just showed you. And you can pass that on to Python. It's very simple to implement, but I just showed you that the structure in GraphQL core is class-based, so this is not compatible. We would need to do further processing in Python, and this is slow, and this is maybe not what we want in the first place. The second approach would be to actually mirror the Python types, so to fake the types from Rust, build types that have an equivalent structure, an equivalent name, and equivalent fields to the Python types, so we can actually work with them in Rust. And the big advantage of this is that it's a type safe option, because you can directly see in Rust, am I putting the right type into my fields? And it's also very idiomatic. You can initialize it like any other Rust structure. But, however, you have some duplicated code with that, because you need to duplicate the entire abstract syntax tree definitions from the classes when working with that. And now you might wonder, okay, you have a lot of instance checks. How can we pass them if we work with something like this? Because it's not the same type as the GraphQL core Python type. And that's the beauty of Python. If something doesn't work, you just override it. And in this case, we just override the class method to return the import of the original field node from GraphQL core. And in that case, it just starts working again, because instance checks usually rely on the class properties on Python types. And the third option is to instantiate the Python types from Rust. So basically, we import our Python types, and we call the constructor from Py03. So in this case, down here, you can see the constructor call. I omitted all of the fields that we pass onto the constructor. And this is basically a great option if you don't want any type duplication, and you want to ensure that there's no missing fields. You're using exactly the same type. that you didn't make any errors during synchronizing the types from Python to Rust. However, you have a large lack of type safety. You can't really see what kind of types the constructor requires. So, for example, you see call bound, and we are calling it with the KW args, the keyword args. And the problem is we need to check the Python code to actually see what this constructor requires. And we can actually only understand this type really if we look at the Python code. So it's a lot easier to work with Rust-defined types. Here we have the 3 types again, just for comparison. And as I already said, the first type, we cannot use it in our project because it's not compatible with GraphQL core. We would need to do further processing in Python, instantiate the AST in Python, and this would be slow again, and we want to be performant, so we just drop this option for this regard. So there's only the 2 other options, and the best way to compare them is using a benchmark, and this is exactly what I'm going to show you here. On the left, you have GraphQL core for reference. Then in the center, you have the mirrored types. And on the right side, you have the Python types. You can see a big performance difference here. And the data is from the parsing time, so the pure string to abstract syntax tree time for a large query, a very large query I chose in milliseconds. So you can see GraphQL core takes 80 milliseconds, which is very slow for a parser. Then the mirror types are super fast, and you have little conversion overhead to transfer these types to Python. And lastly, you have the Python types, which again come with a conversion overhead, but it's still twice as fast as the original Python implementation. So this might seem like a large difference, and it might seem like an easy switch. Okay, use the mirror types, it's the fastest, it's the most efficient solution. But actually, if you look at the entire request execution, it's a different story. So here again, we have on the left side the GraphQL core timings for reference. It's a different query, a medium-sized query. And you can see validation takes up most of the time of processing a medium-sized query. Execution on top of that doesn't take up much time because for these benchmarks, I've used static data to eliminate any additional constraints like data fetching. But you can see that mirror types execution is a little slower than Python types execution. And it's not a big difference, but it's about 20% in our testing. And this increases with the size of the abstract syntax tree. And the reason for that is the data conversion and the data access you incur when you're using Py03 defined types. They all come with an overhead. Whenever you access them in Python, you have a read overhead, you have a conversion overhead, for example, converting the Rust list structures to Python lists, and so on. And this really makes a difference for larger queries. I'm going to show you in a second. So really, it's not an obvious decision whether to use mirror types or Python types in our case, and it really needs some further benchmarking. In general, my recommendation is existing Python types might be slow to instantiate, as you just saw, and they might have some disadvantages in readability and idiomatic use in Rust. But when read access matters a lot, use them because they don't have any overhead. And for all other cases, I really recommend using mirror types if you have a scenario similar to ours, where you need to integrate with an existing code base, because it's just easier to read, it's better to work with, and it's more comfortable to work with. So these are some preliminary results from GraphQL core. Now I'm going to show you the full results from using the technology in Strawberry GraphQL, because this module, of course, works with any GraphQL core compatible framework. So this would work with Graphene as well. This would also work with Ariadne, but I haven't tested it yet. But Graphene and Strawberry would work because we're using the same shared interface these technologies use. And here are some benchmark results. I used Codspeed for all of the benchmarks, and you can see, again, the same result. When you execute a small query, it's about 4.5 times faster, but the larger the queries get, there's some overhead, and the execution overhead also kicks in. Because for large queries in GraphQL, parsing and validation are not the limiting factor, but execution. So you can see, when you have a larger query, it's 48%, and for a very large query, it's maybe 10% performance gain. But it's still significant, and it makes our implementation faster, reducing the CPU load. So basically, based on that, my recommendations for a migration approach to Rust are as follows. So first of all, when you're implementing a Rust project, really look at your current code base, identify some bounded contexts, so basically parts of the code base that belong together, parts of the code base that do a common thing like parsing or validation in our case, and identify the interfaces between them. Like in our case, the abstract syntax tree, which we can use to communicate between these approaches. And for a very first version, for a quick win, prioritize isolated and CPU-bounded tasks. You can still worry about networking in a further step later on, but this is where you have a lot of performance gains to win. And when you do that, also think about data exchange. That means how often do you need to call back from Rust into Python? Is it many times, or do you just need a single callback? Because this really influences performance. And another important part is to plan incrementally. So piece by piece, I started out with the parser, then I added the validation and saw what is the impact, what kind of things can you do to optimize performance even more, and maybe what are the variants you can choose, for example, in my case, the mirror types or the Python types to improve the performance, and what is the impact of each variant. And in order to do that, you need constant performance monitoring. As I just said, Codspeed is amazing for that. You can just have performance monitoring in every PR. It's not a sponsored endorsement or anything, but I really like using it. We use it for all of our open source projects, also in Strawberry, and it's free for open source. So this is great, and it's been very helpful to monitor the benchmarks and see if we broke anything in the next release. And yeah, to summarize what we learned today, we took a quick deep dive into GraphQL internals. You learned a bit about the abstract syntax tree in GraphQL, how parsing and validation work, and then we discussed some patterns on incremental Rust migration, especially some useful approaches when integrating PyO3 in existing code bases. But of course, this is just the tip of the iceberg. You can learn a lot more about integrating Rust with Python. So this afternoon, there's a PyO3 workshop. I think it's booked out already, unfortunately. And if you're curious about Strawberry, stay up next for the next talk by Thiago, which is going to help as well, I think. So that's it. Thanks you, everyone, and yeah.
Thank you very much for this very interesting talk. So we have one question on the slide. What are the next steps?
All right, so the next steps are to work even further into execution. I told you it's a challenge for us because we have a lot of callbacks. We work a lot with async code, but there's still some steps where we can save on performance. For example, field collection, that's a step of execution that actually happens before we call any resolver. And next up, we want to see just how much logic from Strawberry we can convert to Rust, really. So for example, in Strawberry Django, without wanting to spoil too much from the next talk, we have a query planner, and that actually takes in your GraphQL syntax tree and generates database queries from that. And we want to see if it gives performance improvements if you convert that to Rust as well, because it's, again, a step that is very CPU bounded. You can outsource it before running any queries to the database. And up next, we'll see just some inspiration, maybe work on plugin compatibility, extensibility, some very important topics.
Thank you. And another question, why not calling GraphQL from Rust directly?
So I'm not sure I understand the question directly. Could you maybe clarify what you meant? Maybe who asked the question? If you don't want to show, it's fine. But if you're referring to calling the resolvers from Rust directly, so like data resolvers, that's due to the overhead we might incur, and especially due to the problems with async I/O this is going to get. Does that go in the right direction? I'm happy to take any clarifications.
Well, it probably does.
Okay.
Okay, another maybe a bit confusing question for me also, but given that this PyO3 new version will remove some overhead in Rust Python due to Git, have you any plans to rerun benchmarks using pure Rust types?
Just pure Rust execution, not in Python, no, because we still want to support Python and we need to support the Strawberry schema. Benchmarks using pure Rust types without the PyO3 overhead, that's definitely another step. It's not planned immediately, but it's a nice project, and I can see myself doing it in some time when I have some free time, definitely.
There's no more questions here. Do someone want to ask the old-fashioned way?
All right, thank you. Thank you everyone for coming.
Thank you very much.
yeah, Eric did like such a great job. Like he just fucked me, yeah. Yeah, like there's no way my presentation is as good as this. Maybe it is. Diego, you want some? Oh. What is this reference? We were talking about having a nice it's like a herbs that's used in Ukraine a lot, or in Uzo. Yes, but I mispronounced it, yeah, and that it actually means the plural of Anawi. Portuguese. Maybe don't explain that during the talk again. Let me just prepare here, otherwise it won't be ready. Can I just start? Good. And I pronounce it the Dutch way, which is apparently a bad word. I'm always jealous of the UI that is better. Looks so nice. I go Finder. Aesthetically, I think it's very good. Yeah. What do you think? It got quite inconsistent with the regional updates. Yeah. Like there's like small differences in like different windows for like the client-side decoration stuff, and it's subtle and annoying. But I don't use it much, so that's fine. Yeah, I'm very much so used to client-side decorations being different. Yeah, that's different. Three different versions for no. What do you use? Oh, okay. Well, it would be nice to have this stuff, but I can't suppose I can't like run the program on like a mirror actually. Yeah, it's because I'm going to have like a pointer, so probably it's better to have a mirror, right? Help me out. I'm very bad at this. Ah, okay. And how do I make this? Like, okay, it's already in. If you want to like change it to, I don't think it was just combine. He's fine. He's prepared. I swear. Okay, I think that is. Yeah. Wait, are you here? I came. Well, I was in Rome for a few days, but then I got to Florence yesterday. California. Can I have some water here? Oh, I need this is part. This is parking. Okay. I need this one. Oh. Yeah, I don't know. I guess we'll have to watch the video. Oh, really? You were just right now. You want me to buy one? Yeah. I've been to Berkeley for a number of months. That's why I messaged Rainier in the very close. It was his question, and he was actually sitting next to me. Which is going to really reduce overhead even further. So maybe we'll get another point. And then there's also the Berkeley Hills. Yeah, nice. Yeah, that's cool. But it went okay. I had a few like where I lost my flow, but it happens. It's happened for. I'm okay. Like, yeah, cool. If it was understandable, and not, how was the speed? Was it okay? Like not too fast. Okay, good. Obviously, I already had some background. Yeah. You want to talk about GraphQL or start? I have a class with actual that is good. And if you wait till the end, you can ask all of us. So, all of us. You. We had two people. Now that I'm seeing it, have a notation. Like the one with notice. Yeah. And strawberry become one. Yeah. Exactly. So if there are a lot of different distributions of roles, so it's fine. Yeah, unfortunately. I should have saved it for later. But I assume you are much better now. Yeah, I'm really, really oh, and like, seriously, like, it was awesome. Thank you. Really good job. Yeah, I'm I know some point I was really tough. It's okay. But you did a really good job. Thank you. Really. Something. I'm sorry? Company. What is? What is the microphone? So that's. No, it's not. Now it's disabled again. Ah. Okay. You can disable it if you have it. Yeah. No, I think it is fine. Yeah. You just need to colon W quick. Okay. If I will try to avoid like pressing it, like clicking on it. Yeah, because it will do that.
Hello, hello.
Thank you, everyone, for coming to this session. Let me first remind you to ask the questions on the Slido. You have the link on the website in the schedule section. So we will have the QA at the end. We're having here Tiago Bellini. He's going to talk about GraphQL, just to continue on this, what you heard in the last session. So here you go.
So thank you, everyone, for being here. Let's start. So first of all, who am I? Like, my name is Tiago Bellini, as he said. I'm come from Brazil. Came here to talk to you about Strawberry. Very long flight, I must say. Have been developing Python solutions for the past 14 years, at least. 6 of those were developing GraphQL backend solutions, mostly using Django, but not only that. I am also a part of the GraphQL, the Strawberry GraphQL development team, such as Eric, which was presenting before me. I am also the maintainer of the official Strawberry Django integration, and currently I'm working as a senior software engineer at Parade.ai. So first of all, like, what is GraphQL? Like, Eric did a very brief explanation about it, but basically, and going over it again, GraphQL is basically a query language for you to that defines how to. I'm sorry, I'm a bit nervous, but defines how your data is structured and how you can fulfill that data and retrieve data from your server. This is a nice picture. I like it to explain like the main difference between it and REST, which is basically what most developers use in the backend. So, for example, on REST, we usually will have like an endpoint to retrieve a cheeseburger. And it comes with everything, basically. If you ask for it, you have the bun, the onions, the tomatoes, the lettuce. But in GraphQL, you can define a query to get a cheeseburger, and you can just get what you want. Like, if you don't want onions, you just don't add those. If you want a vegan patty, you can just like ask for it and skip the cheese, maybe, if it is a vegan as well. So that is like a fun illustration, but it summarizes very well like the main difference between REST and GraphQL. So basically, some of the pros, basically, as I said, no overfetching and underfetching data. You basically get what you want, and just that. Like, if you want the ID, you get the ID. If you don't want it, you don't need to fetch it, and it will not come to you. It is totally. It has a lot of type safety. Like, the server is supposed to do a lot of type validation, not only from the query execution itself, just like Eric was talking about, but like when you return the data, if you say that it returns a string, like, it will not allow you to return null or like an integer or something like that. It allows you to avoid endpoint redundancies, such as that, like, you don't need two endpoints, one to retrieve a cheeseburger and another one to retrieve a vegan cheeseburger. You can just have one and have different variables, pass different variables to it. It is easy to access relations within the graph. Like, everything is a graph, so it just makes sense. Like, you can, as long as like lettuce can be an entity there. When you are accessing the cheeseburger, you have access to the lettuce as well. No API versioning required. You can just change, like, this field is called foo. You can create foo v2 and deprecate foo. No need to create another API endpoint for that. But of course, there are some cons. Like it has like a steep learning curve. You need to be thinking in graphs. Caching is more complicated. Like for a very common REST GET request, you can even use the browser to cache it. While in GraphQL, it's basically impossible. Most GraphQL, like you can do GET requests, but most will usually use post, and browser by default will not cache post requests. There are some potential security concerns if relations are not resolved correctly. Like in theory, you can transverse your whole graph starting from the cheeseburger. You can transverse it all. So maybe you don't want someone to access the lettuce color attribute for some reason, but like if you don't protect it, everyone will be able to access it. And also some potential performance issues if relations are not properly handled. And that's the reason why I am doing this talk. Like, don't need to fear the cons because Strawberry is here for you. A lot of what we do at Strawberry is to make it easy to avoid those cons. So basically, how it works. This is a very simple example. You define your schema. So you start by defining your type. So suppose in this case, like we are defining here a user type, an email type. As Eric showed you, we have like some scalars in here. So the username, the name itself, they are strings. The birth date is a date. There are relations in here. The email, for example, the emails is a list of emails. Which is this other type, and so on. Like we have like a circular dependency in here. Like from the email, you can also access the user if you are accessing the email itself. And with those types, you can create queries and mutations. Like query is the equivalent operation to a GET request, and the mutation is the equivalent to a post, put, delete, or anything that you want. Like it is a verb you can have. Like in this case, we have a create user, but you could have like an update user, a delete user, anything that you want. But like, I don't know how many of you like are familiar with GraphQL, but if you are not familiar, maybe this doesn't make just that much sense to you. But what if we can write that in Python? And well, spoiler alert, we can, thanks to Strawberry. So if we take, for example, this, the user and the email, we can very easily, like you are all familiar with data classes and how they work. So it is very easy to do this conversion, like getting the user and getting the email and mapping those to data classes. And later, we can just transform those into Strawberry types by replacing data class with Strawberry type. It is that simple. Like. Strawberry is basically a wrapper on top of data classes. And like in theory, it is just that, but it has much more, and I'm going to explore more as I go through this presentation. The query itself, you saw the example that I gave there. You can request, like me, suppose that you are accessing something and the user is logged in, so me should return either like your user or null, in case like you are not logged in. You can retrieve like a user, given its username or a list of users. And those are all just translated to Python functions, in this case methods. So you can even see, like, for example, the user, it receives like a username argument, and you can just resolve it here and return. It is expected to return the user object from the data class. The same for the users here. It is expected. I'm sorry. It is expected to return a list of users, and you receive here the limit and the offset that were given while this was being queried. The same goes for the mutation. Like it works very similarly to a query. Like in this case, of course, we are mutating mutating the data, we are creating a user. So we are receiving here like everything that we need to create this user, and we are just going to return it, just like the query example. So there is not much difference between queries and mutations. There are some internal ones that I'm not going to go into details in here, but like in theory, they all work very similarly to each other. So how do you query your data later? So you just created your backend and you want to query that data. And you can do that by doing this. Like you can, this is going to be the body of the post request. This is the language itself that GraphQL has to query that data. And it basically says that, oh, I want to get the me field. Inside it, I want the username, the name, the age. And also I want emails. And from emails, I want the email and its primary, which, when being resolved by the server, is expected to return something like this. So if I am logging in this backend, you can see that I am getting back like my username here. My name is null because I did not define it for some reason, my emails, and so on. And you can see that it has specifically the fields that I asked for, not more, not less. It is exactly what I asked for. Also, another example for the users, like just for the sake of having a second example, like that one was returning one object directly. This one I am doing like a listing, and I'm just asking in here for the username or the name because I am doing I am maybe populating it in a list, and I don't need that much details. I just need like the username and the name, and this returns me a list of users. So how can we, now that we know the general of how GraphQL works, how can we write general GraphQL APIs using Strawberry? So this is very similar to the example that I had before. I have the user type in here. This is also presenting something new in here, which is a Strawberry field. So you already know about this, but this is new. This is a way for you to define like each field inside a Strawberry type is going to be resolved to something. By default, it's going to be resolved to itself. So if I have a user type, a user instance, when asking for the name, it's going to resolve to user.name, of course. But when asking for the age, this function is going to be called, and what it resolves to, it's going to be returned to me. So in this case, I'm just doing some calculation to check like the age of the user because I have the. I'm sorry, where was I? Okay. Okay. I'm sorry, because I have the birth date, no need to instantiate it with the age as well, like the object itself can calculate the age given the birth date. And then I have a query, as I told you, the query is the root where I will do get operations, and I am asking for the user, and I will return it and just instantiate it as a Python data class. I notice that I am not passing the age to it because it's going to be automatically calculated. The same here for like like to show some examples with relations. In this case, we have friends in here. So when returning, I'm just instantiating friends as a list of users, creating those other users, and also emails and creating those as well. So you can see that it is very idiomatic Python using data classes. So this is basic Strawberry doing Strawberry stuff. And now, how can we integrate that with the Django ORM? Okay, so the first thing that we need is, of course, like to expose a way to request the Strawberry itself. And we do that, like everyone that is familiar with Django knows about this. You have like URLs file where you define routes, and you point a route to a view that is supposed to handle those GraphQL calls. It is a single point, when you have a GraphQL API, you don't have a lot of endpoints, you just have one, and that one is supposed to resolve what you passed in the body, just like I showed in some examples before. So that is basically what you need to be able to start serving GraphQL queries. You can see that I'm passing here a query in the mutation, which can be one of those that I defined here, for example. I just defined a query here. So this can be a query that I can pass in here. And of course, we have both views for WSGI and ASGI. Strawberry is async IO friendly, and known as async IO too, so you can choose whatever you are using in your Django deployment. When you first try to send a GET request to it, you are going to be presented with a screen like this. It is just like a playground to help you. You can check your scheme in here. You can make a query, check the return JSON here, just to show how it looks like, and then you can actually start mapping the types, your ORM to your types like this. So in this example, suppose we have like a user and an email, just like the examples before this one. We have a user with first name, last name, birth date. We have email with email is confirmed, is primary, and also the foreign key to the user to create the one-to-many relation from the user to it. And like the first thing that we can do is just to use Strawberry directly. So in this case, we're just going to map the type directly, so we can create an email type, mapping it the same way that we have it defined in here. Also the user type. And you can see that, for example, for emails, how am I solving this? So let's go from the root in here. I have the query. In the query, I have a user. I can retrieve a user given its primary key. So when I call it, I just will do a user.objects.get this primary key and return and instantiate this user type, pass into it the user primary key, the name of the user, its birth date, and inside here, because I have like the user, I'm sorry, I think I forgot to to actually, oh no, I'm sorry, I'm dumb. This is the user's primary key, it's not the email's primary key. So when I'm returning here the emails, I am just like doing an email.objects.filter to get the user emails in here, and I'll as well instantiation the email type. And this is going to return a list. So this is like the most simple way of working with Strawberry, and that's how you're usually going to work with it when doing any fast API, SQL Alchemy. There is like a SQL Alchemy integration, but it's kind of new. So even with Django, you can always do something like this. And in here, I'm just going through details on what is. Oh no, I'm sorry. I am. Yeah. So instead of using like instantiation the type yourself, you're just doing duplicated work. Why not just return the model itself, since it has like a similar protocol? If you try, as I said, like if you try to solve email.isConfirmed, and you have the email object from the ORM you can actually solve it. It's not a big deal. So why not return the model itself instead of having to instantiate it here like this? So you can basically use Strawberry Django for that. So in this case, I am using Strawberry Django.type and passing the actual model to it and doing the mapping. I am still doing going through each attribute here and mapping it with their correct scalars, but I'll show in the next slide how this can be even better, but this is the easiest way to do this. And what's happening here, we are using Strawberry Django.type to define the type itself, so it creates the relation between the type and the model. Emails is defined as a list of email type. So you can see that we don't have a resolver anymore. We don't have a function that will do email.objects.filter to do the listing anymore. Strawberry Django will basically create a resolver for you that by default will resolve this into a list using the relation itself. The user is assigned to a Strawberry Django.field, which basically will, when it's exposed like this, it will automatically create a resolver that receives a primary key, and you can resolve the user giving its primary key, and the same for the users. Because it's annotated with a list, it will automatically generate resolver that resolves it to a list of users. By default, all users in the database, yes, but this is just an example, of course. You would not probably be going to expose your whole user base in your system like this, but just for the sake of the example in here. But as I said, this can be even easier, even better. So we do also provide an automatic type generation in it. So because we are doing this link between email type and email, we know that is confirmed is a Boolean field. So why do we need to do this again? There's no need to do that. So if you can just annotate it with strawberry.auto, and the integration will basically introspect the model when the type is being created and annotate it with the correct annotation. For example, a char field is going to be annotated with a string as a string. A char field that can be set to null is going to be annotated with a string or none, and so on. So what else can the Strawberry Django integration do to facilitate your coding? So the first thing is, I already told you about this, but it acts like the Strawberry type acts as a protocol for the model. So when you return the model, and as long as the field that you defined matches the name of the field that you have on the model, it's going to be resolved correctly. It has automatic resolver generation, as I also showed you before. You can, this is always going to, you don't need to worry about resolving the user's emails unless you want to restrict it. And I do have a good example that is coming soon in this. This is where it starts to get more interesting. You can, for example, filter results. And how do you do that? Also defining other data classes, in this case, Strawberry Django.filter, which is, we'll use the same syntax that we use to define types. This is a very simple example where I am defining a user filter that can receive a primary key. It is using the auto as well, but since it is linked to the user model, it knows that this is a primary key field, probably a big integer field, but if it was using a UUID, it would map to a UUID scalar. And then I can pass it to the users in here. So what I am doing here is to tell, when you generate the resolver add to me filters on it, so like the user can do filtering using this. The same goes for, it can even be nested, just like in this example. I have an email filter, and you can see that I am reusing, and oh, there is an error in here, I'm sorry. This should be written user filter. So because I can go nested, like when filtering for, if I am querying for emails like this, maybe I want to query for all the emails for any specific user, giving the user's ID. This is a nice thing to do. And in this example as well, just for the sake of curiosity, I am giving the filters, I am passing to the type itself, which basically states, oh, every time that you generate a resolver that returns a list, add the filtering for me. And what this will do, it will basically generate this query for you, so you can see that this user filter is generating, like, it is not a type, it is very similar, but it is like a GraphQL concept. I'm not going to go into details in here, but it is an input that it can be received as an argument for the users in here, so you can use it to filter it in here. The same for the emails and so on. Okay, here is the emails example. You can see that you have the user filter in here, which was defined in here. I just didn't add those to the same slide because it just gets very big. But suppose it is like in the same file. And yeah, I'm going to actually, because I am running out of time a bit, I'm going to skip this part of lookups. But we can, like, if you have questions, we can talk more later, and I can give more examples in person. But you can, there is a way to use the Django lookups inside the filters as well. This is just an example, like when you're going to query it, how do you actually use the filter? So in this case, I am filtering emails and filtering everything that ends with gmail.com or yahoo.com, or in this case, as I showed, using the nested filtering. I am passing like the nested filtering to the user here and asking, oh, get me all the emails that belongs to the users of IDs 1, 2, and 3. So it didn't make too many sense then, but now you can see how this can be useful. The same goes like this. I'm going to go really quickly on this because it's very similar to filters. Like you can define an ordering type, so as a way for to ask the results to be returned in a given order. It is going to generate this anon, ask or desk, and you can just query for it. And for example, in this case, I was asking for the emails. I actually have like an example in here. I was asking for the emails, and I wanted to like I can. In this case, it is not in the same example, but I can have it filtered by the user, and then ask to order by the user's PK ascending, and secondly, by if it is confirmed or not descending, and with that, I can have like a very complex way of querying and listing emails. There is a way also to generate automatic pagination. You don't have to define any types in this case. You just tell, when you, like for this user's listing, add pagination arguments to me, and we'll just add an offset and a limit to the query, and those are going to be used when resolving the query set. Those are going to be used to slice the query set and do the pagination for you. So, for example, if you want, in the case of emails again, if you want to retrieve the 5th page of a 10 results per page pagination, you can just ask for like an offset of 40, limit of 10, and you just got the 50th page, and so on. Again, this all can be combined. You can filter, order, and paginate at the same time. This is just for the sake of simplicity for exampling. There is also, this is another huge topic that I mentioned before, like security. It is very important for you to protect your fields. Like as you can see in the examples that I showed, like anyone that gets the user can access all of its mails, and that is probably a security concern. You don't want that. Strawberry Django does. Thank you. Strawberry Django does provide a set of useful permissions that you can use to protect some of the fields. By default, you can also define your own. But in this case, for example, I am protecting the users themselves. Like who can list users? Whoever is a staff, like whoever, anyone that works with Django knows that the default user has an isStaff attribute in it, and you can this permissioning will basically just check for that. If the user is not a staff, it will not allow him to resolve this. Then, having resolved the user, who can access the user's emails? In this case, just super users. So even though the staff can get a list of users, they can't see the user's emails in this scenario. And also the birth date. Who can see the birth date? Whoever has this permission, this can see birth date permission, which is basically a custom permission created for Django. But you can always use the ones that are already created by Django, as they create, I think, 4 by default for each model. So what are basically some additional features that are not going to be covered here, but like the integration is async friendly. You can, as I mentioned, you can use it on the default Django, but now Django is all about async, so you can use it on ASGI as well. The integration also provides some huge mutations, so there are mutations to easily create, update, and delete models that you can use. It does provide some cursor pagination as well. I showed an example using limit and offset, but sometimes, and actually most of the times, you do have a more complex scenario where you want to have more control over it, and you can use cursor pagination strategy for that. It does provide a query optimizer. I'm going to talk very briefly about it. And the debug toolbar integration can, when running sorry? Yeah, that I showed before, you can check the SQL queries that are going to be executed in each of your requests. And there is a Django channels integration for subscriptions not covered in this presentation as well. Like, it is too short to present everything that the integration provides. But like going really quickly now here, some common pitfalls to pay attention. Like the first one is not protecting your graph. Like as I said, like in this case, you are just allowing everyone to access the user's emails. How to solve that? You can either have like a custom resolver for it. In this case, as you can see, if the user is not himself, like the root in here is the user. If he's not himself or he's not a staff user, this is going to raise permission denied. Otherwise, it just returns the emails. Or you can use the permission system that I told you about before. Not thinking in graphs. So in this example, you have a user type. You have a user with emails type, and you are like exposing. This is very common for people coming from REST. Where, I want like to, I have an endpoint to expose a user with the name, and I have another one where I add the emails. There's no need to do that in GraphQL. You can have just one, and like the client decides if he wants to get the emails or not. You can have thousands of fields. As long as they don't request those thousands of fields, it's totally fine. Going to skip this one because I'm not going to have time, and I'm sorry about that. I think I spent too much at the beginning. And not paying attention, this is the latest one that I want to talk about, not paying attention to the N+1 issue, which is something inherited to GraphQL. Basically what happens, because we never know what the client is going to request in this example, I am requesting for the user. But inside the user, is the client asking just for the name, or is it requesting for the name and the emails as well? If it is requesting for asking for the emails, you just have an N+1 issue there, because if you have 1,000 users, it's going to make a request to get the users, and then 1,000 more to get each user's emails. We could easily change that by doing a prefetch related. Anyone that works with Django probably knows about this, which is going to reduce this to just 2 requests. But still, this is much better, of course. But we are still retrieving a lot of data that we are not going to need if the user is not asking for emails. So how can we avoid that? The basic solution for that is using data loaders, which is mostly an async solution. So if you are using non-async Django, it's going to be harder for you. There are some solutions out there, but I'm not sure how good they are working. But basically, this works like a promise. When doing the resolution for the emails, you are going to ask for a batch please load this user's emails for me, and the other user is going to do the same, and this is going to be batched together. And there is a resolver function that later is going to resolve all at once and return the results to each of the promises that just got generated. In this case, it is actually a future object in Python, but anyone that knows it knows that it is basically the same as a JavaScript promise. But how does Strawberry Django integration automatically solves that for you? It will introspect your query and automatically do .only, .select related, .prefetch related for anything. Oh, 1 minute. Okay. Okay, so unfortunately, I just ran out of time. I'm sorry. As I said, I think I just spent too much at the beginning. Oh, sure. Is there much some questions? Oh, sure. Let's do this. Feel free to reach me out outside of here if you want to know more about especially the optimization stuff. It's one of the greatest stuff about Strawberry Django. But read me the questions. Thank you.
So real quickly, what are the main differences with Graphene package for Django?
Okay, I'm not sure if I am going to be able to properly reply to that, because I have not been I have been a Graphene Django user in the past, but I have never touched Graphene Django's code. Eric is someone that can probably answer that better, as he is a former Graphene developer. But I would say the main difference is mostly the strawberry itself. Like both integrations, I think they do a similar job, but the graphene one just uses graphene syntax, and strawberry one uses strawberry syntax. And also, I think the optimizer that unfortunately I failed to show you, but like models apart, I think it is a great it is a great job done there.
And there's another question. Isn't the usage of class names query mutation under strawberry type limitation? Well, isn't the usage of class names query mutation under this strawberry type annotation limitation? If that person wants to define more than one query or mutation.
Oh yeah, like it is. Again, there is so much to talk about. There is just no time. I showed some examples where I had a lot of queries defined. Usually, like the query itself is a type. You have one in your schema. It is very common for people to just define, like those are queries related to a user, so it is going to be defined in a user file. Those are related to, I don't know, in this case, emails, for example, and those are going to be defined here. And there are tools on Strawberry that allows you to merge two types to create one. And so everything is exposed together, but still you can have a good organization code-wise. Hope that answers the question.
Thank you. Is there any more questions maybe to ask the old-fashioned way? Okay, thank you.
Thank you.
we're having here Shirley Di Castro. She's holding a PhD in reinforcement learning from Technico in Israel. She developed and implemented AI models in different domains. And currently at MB, she's working on generative AI and machine learning. We are going to hear about synergy of LLMs and GraphQL to see how it can help doctors access patient data. Thank you very much.
Allow me to introduce you to Noah and Itai. They've been a couple for many years, and they've been trying to start a family. Unfortunately, they had the difficulties in convincing naturally, so they decided to seek for an assistant from a fertility clinic. Now meet Dr. Tsarfati. She is a fertility specialist who runs her own clinic. Noah and Itai arrived to her clinic, and she started to ask them about their conceiving attempts, and she wants to see their medical records. She recommends them to do some blood tests, some ultrasound scans, some hormonal tests to assess their fertility condition. And eventually they decide that they want to proceed with IVF treatment. Okay, so Dr. Tsarfati she wants to prepare for this treatment. She needs to decide what is the best day for egg retrieval. Therefore, she needs to know what was the highest level of a hormone called estradiol in Noah's hormonal tests. Estradiol is hormone is very crucial in the ovulation process. So Dr. Tsarfati accesses her computer and she starts to search for this information. But she just can't find the answer for this simple question. Where are the hormonal tests stored? In which system should I check? And where is the... Noah sent me her medical summary. Where is it? Where can I find it? As you already understand, one of the main challenges of doctors is how they can query the medical data of their patients and get answers. While this data exists in the databases, it's deeply buried and they have no easily access for it. So this is exactly what we're going to talk about today. This was the challenge that we wanted to solve for the doctors and medical care teams in the fertility clinics we collaborate with at MB. We are a startup, and we specialize in developing a platform for fertility treatment monitoring, specifically for doctors and medical care teams. So today I'm going to share with you the development process we had at MB for our tool. What were our considerations, which technologies we considered, and I hope to convince you why we eventually chose to use LLMs together with GraphQL for this tool. I will share with you also code and some tips. I am Shirley Di Castro Shashua. I'm from Israel. Miei genitori sono da Roma, allora so parlare italiano abbastanza bene. I'm a senior data scientist at MB. In my professional background, I have BSc in biomedical engineering and a PhD in reinforcement learning. This is me at my most favorite vacation, skiing. And the reason I put these images here is just that the last time I visited Italy was just 2 months ago when I went for skiing in beautiful Sella Ronda. I'm a mother of 3 sweet children, Daniel, Nadav, and Shaked. And as you know, many couples are trying to start a family, and I'm very excited, together with the MB team, to be part of their journey. Okay, so this is Dana. Dana is our CTO at MB. One day she comes to us and tells us, guys, the doctors at the fertility clinics, they want us to develop them a tool where they can just ask questions about the medical data of the patients, like the question of Dr. Tsarfati, what was the highest estradiol level for Noah Sheleg, and just get the answer. That's it. They don't want to search for the information. They just want it fast and now. They have no time. So if you want to develop this kind of tool for your organization, this is your time to pay attention and listen. We took this mission on ourselves. Yaron, who is the backend developer, and me, Shirley, the data scientist, who at this point just I became the professional Gen AI of the company. So we started with defining what is the flow of our tool. So on the one hand, we have the question that we receive from the doctor. And on the other hand, we have the answer that we would like to provide him in free-form language. So we start with the question. What do we assume about the questions of the doctors? First, we assume that the question is going to be in free-form language, just like a doctor asks his colleague. Next, we assume that the question may be complex. The doctor may ask more than one question. He may ask a question that requires us to take several databases in order to answer this question. And we want our tool to be very flexible to any kind of doctor's question. This is the thing. We do not know what the doctor is going to ask. He can ask about one patient. He can ask about several patients. He can ask about clinical activity. We have no clue. So we must that our tool will be flexible to any kind of input. What about the answer we would like to provide to the doctor? First, we have to make sure that our answer will be authorized. That means that only staff members that have permission to see the data that they are asking about will receive the answer, the authorized data in the answer. Next, we want to make sure that the answer is relevant and accurate. Relevant, that the response really answers the question, and accurate, that in the answer we will have only real data from the database. We don't want that the answer will include any incorrect information. Oh no, Shirley, how are we going to do it? How are we going to develop a tool that is accurate and flexible and secured all at once? Relax, Yaron. Don't you know, didn't you hear about LLMs, large language models? They've been tremendously developed in the past few years, and they allow us today to tackle tasks that we could only dream of. Large language models can summarize, can translate, can generate code, can answer questions. This is exactly what we need. Okay, so how do we combine LLMs in our tool? Naively, when we get the question from the doctor, what we would like to do is just to send it to an LLM, give him the relevant data, give him the doctor's question, and tell the LLM your task is to generate an answer based on the questions of the question of the doctor in free-form language. Sounds easy, right? But here's the problem. How do we make sure that we send the LLM only the relevant data from the database? We do not want to send him all of our data from the database. It's a huge amount. Our task is to narrow it down, to focus, to provide to the LLM only the data that he needs in order to answer the doctor's question. So how are we going to do it? We simply use another LLM for this task. So this is the first LLM that we're going to use. To the first LLM, we're going to provide the doctor's question, but instead of providing him all of the data from the database, we'll provide him the database structure, the names of the tables, of the fields, and we will ask him, instead of generate me the answer, generate me a database query that will fetch data from the database that is relevant to the doctor's question. Then, hopefully, the LLM will generate me this kind of query. I'll run it on the database. We'll get the relevant data from the database. And now we can do what we wanted. We can now ask again the LLM, here is the doctor question. Now here is the relevant data because we already fetched it. Now if you can please generate me the final answer. So now what we've left is to decide how are we going to query the database? Which language or that database query language are we going to choose? And this will be our focus. Listen to me, Yaron. I see tutorials. I attend meetups. I get updated in the last developments, and I tell you that what we need to do is to ask the LLM to generate an SQL query. Then the LLM will generate the SQL query according to the doctor question, according to the database structure that we'll give him. We'll run it on the database. We'll get the response from the database. Then we'll send it again to the LLM, and we'll get the final answer. Easy, easy. the combination of LLM and SQL, it gives us the flexibility we wanted. It gives us the ability to answer complex questions, because in SQL you can do joins with all the tables, you can filter on all the fields. It's perfect for us. No, 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 no. Surely there is no way. There's no way I'm letting an LLM generate an SQL code that's going to run directly on my database. No way, this is so not secured. What if the LLM will generate a code, an SQL query that will delete me tables from the database? Or what if the LLM will generate me a SQL query that will fetch all the data and will crash my system? There is no way. Relax, Yaron. This is what all the blogs are saying we need to do. Even LangChain, they say so. This is what we need to do. No, no, Shirley, I'm sorry. There is no way I'm going with it. There's also the PII problem that we need to consider. PII, personally identifiable information, it's crucial. As we are a healthcare company, we're bound with regulation. So we need to make sure that there is no way no one can link between a patient's personal data and the patient's medical records. So when you are saying that the LLM will generate an SQL query, the LLM will going to filter according to the patient's name. But here's the thing, we do not store the patient's name in our database. So you just cannot run this query. Instead, we have separate databases. We have database for medical records, we have a database for personal information. What links between them is a patient ID. Okay, Yaron, so what's the problem? Okay, so forget about patient names. We will provide the LLM with the patient ID, and then the LLM will produce an SQL query with the patient ID. That's it. This query we can run. I'm sorry, Shirley, there is no way, there is no way. It's not enough. There's also the roles problem. The roles problem. Yes, the roles problem. Again, we are a healthcare company. We need to follow regulations. So we have defined distinct roles for each staff member. This to make sure that a doctor, for example, cannot access to data that is not the data of its own patients. So how your LLM is going to generate an SQL query that will know how to limit the access to only authorized staff members? I know. What we'll do is we'll do an SQL validation. We'll validate the query of the LLM, and if needed, we will append additional filters that will make sure that only authorized people can access this data. I'm sorry, Shirley, it's not going to happen. The combination of LLM and SQL is not secured. If you want, I agree that the LLM will generate us a REST API request. With REST API, everything is controlled. The client sends HTTP request to the server, and then it gets back the data. Since I am the one who is implemented in the backend, I have full control of what data can be requested and which data I give back to the client. The combination of LLM and REST API is secured. I can implement any safeguards I want to make sure that there is no accidental deletion of my database and that only authorized people can get the data they need. No, Yaron, not the REST API. No, you know that we have the problem of the overfetching and the underfetching. And it's all because in REST API, the response is predefined. This is a big problem. In overfetching, REST API can give you more data that you need in order to answer the question. So, for example, Dr. Tsafati question, what needs is only the information about the estradiol test of NOAA. So if the LLM is going to generate requests according to REST API, he will use, I guess, the lab test results endpoint that we have. But this endpoint that you implemented, it fetches all the tests of the patients. But we don't need it. It's too much data. And also inside the estradiol, there are many irrelevant fields for this question, and it can overload our database and can slow things down. And there's also the underfetching problem, which is the same thing, but from the other side. REST API can bring you less data that you need in order to answer the question. For example, Dr. Tsafati may need, for the lab lab test, she needs which cycle it was, on when was it ordered, but you did not predefine it in the response. So if the LLM needs this information in order to answer the question, he will need to generate additional queries for other endpoints, and we can't get away from it. We'll need to generate many new endpoints in order to have all the data types that we may be requested by the doctor. The combination of LLM and REST API, we wanted flexibility, we wanted to be able to answer complex questions. Forget it. REST API is ruining it for us. I want us to proceed with SQL. There is no way, Shirley. I agree only for REST API. Oof. Oof. Actually, I understood him. He's got a point. The database is sacred, and any code that is going to be run directly on the database has to be generated by someone who knows what he's requesting, so the database won't crash. And LLMs, with all due respect, they're unexpectable, and they may generate sometimes stupid things. So we just can't allow ourselves to let LLM to generate SQL code that will be run directly on our database. Yaron, what do you say about GraphQL? GraphQL, interesting. Let's see what it means. So GraphQL is a language for query data from the database. It has only one endpoint. Remember, we said that REST API, we had to have many endpoints for each of the data types we wanted to return to the clients. GraphQL has only one endpoint. And also, remember that in REST API, we had the problem of overfetching and underfetching. In GraphQL, we have exact fetching. The client can request only the data he needs and get back only the data that he needs. And this is going to be according to three components of GraphQL: schema, query, and resolver. Okay, so schema. Schema, in GraphQL, you can define types that you allow the client to request. So in our example, we can define a patient type with all the relevant fields. We can define a lab test results with all the relevant fields. And of course, we can define additional types for the fertility clinic. There is a special type in GraphQL called query, which defines what the client can request in order to get the data back. So here's an example of a query that may answer Dr. Tsarfati question. So the query may include the patient data, the name. You can see that the query does not include date of birth. I mean, the client could ask this field, but it's not relevant for the question of the doctor, so we don't need it. And also, we can request the lab test results. In GraphQL, we can also filter, so we can even make it more narrow and get only the data that we need in order to answer the doctor's question. And last, we have the resolver. The resolver is like a bunch of functions that needs to define how we're going to return to the client the data that we defined in the schema. If we define it, the client can ask for a patient data. We need it in the resolver to decide how we are going to fetch it and how we're going to return it to the client. So in the resolver, it's where all the magic happens. The resolver contains a lot of functions that we as developers are going to write. So we can, inside the resolver functions, we can put all the restrictions that we need in order to make sure that we give back the client only the data that we agree that is going to receive. So it allows us to have a more secured fetch, because the GraphQL query is not going to be run directly on the database. It's going to go through the resolver strainer. It allows us to give back the data only to authorized. We can implement this inside the resolver function. And it also gives us a lot of flexibility, because in the resolver, we can implement all the filters that we want and all the combination between different databases. For example, we had a problem with patient name. So LLMs, they understand good language, right? Natural language. So in the query, they can ask for the first name and last name. But inside the resolver, we will implement that if we get a name, we need to check if the name, we have it in the database and we can fetch the user ID. If we have, for the same name, many users ID, so we can give back an error. Okay, and we can make sure that what we give back is authorized, and it gives us a lot of flexibility. The combination of LLM and GraphQL is secured. Surely, I really, really like it. I like it too, Yaron. The combination of LLM and GraphQL gives us the flexibility and the ability to address complex questions. Okay, the only challenge with GraphQL is it will take us time and money to develop it because it's not implemented in our system. REST API, we already have implemented on our databases. SQL is just run it on the database. But GraphQL, it takes time and development time to implement it. But we decided to go for it. So now I'm going to show you how the flow is looked with the combination of LLM and GraphQL. So we said we have the doctor's question, and we sent to the first LLM the doctor's question, and we sent him the GraphQL schema, all the types, okay, that we defined, and we asked the LLM to generate a GraphQL query. So this is how it looks like. First, we defined a class of GraphQL chain. We initialize it with the LLM we want to use. We can use, here, it's an example with OpenILM, but it can be another LLM. And we initialize with the prompt for, first the prompt for the GraphQL query, and the second is the prompt for the final answer. So this is a prompt. It looks very big and ugly, but I'm going to explain what it includes. So the prompt that we send to the LLM has 5 components. First, we're going to tell the LLM what is his task. We're going to say, LLM, you are a GraphQL expert. You know how to write GraphQL queries. Your task is to write the GraphQL query according to, first, the doctor question, and we're going to put the doctor question here, and according to the GraphQL schema, all the types we have. And according to, we also decided to add the resolver signature. You remember we said the resolver is a function, okay? The function, in the function, the LLM can understand what filters he can use, what are the types of the fields, okay? So if we give him also the resolver function, it helps him to make more good synthetically GraphQL queries. Also, we're going to tell the LLM how we would like the output to be. We decided to tell him that we want the output to be a GraphQL query, of course, but also we asked him to give us an explanation for what the GraphQL query is fetching. Why is it important? Because we wanted the doctors to know what data the LLM based on his answer, okay? Because maybe he fetched data that is not what they ask for. So it's important that they understand what was the data that was fetched. And we give him example. It's a good practice in working with LLMs to give examples of what you're looking for. So we can give him, in the examples, a possible question, how we expect a GraphQL query to be synthetically correct. And we also wanted him to give us explanation, so how we expect the explanations to look like. This structure is very important because it will help us to parse it much easier later. Okay, so this is how it looks. It's a function inside the class. So in the GraphQL prompt, it's an F string, and now in runtime, we put the doctor question and the GraphQL schema. We send it to the LLM. So we get the GraphQL query. We need to check if it's synthetically okay, or other checks that we want to do. And then we can run it and get the database results. Okay, so this is where we are on the flow. The LLM generates a GraphQL query according to Dr. Sarfati question. Okay, so she wants to know what was the highest level of estradiol of Noah Sheleg. So the GraphQL query is going to filter on the name of Noah, on which lab test estradiol, and this is the fields that are interesting in order to answer the question. And now when we run it and we get the results from GraphQL, and this is the opportunity to see how GraphQL response looks like, you can see that all the fields in the response are exactly the fields that we requested, nothing more and nothing less. So we get just the data that we want. So here we get all the stadial tests of Noah. So now when we ask again the LLM to produce an answer, what it will look like, we ask what is the highest level, we will append to the question this result, okay? And now the LLM has just the relevant data and he can answer the question. Okay, so this is the second time we send the prompt to the LLM and the task now is just give us an answer based on the database response. And this is how it looks in the code. Again, we have a final answer prompt. It's another prompt, much shorter, very simple. It's an F string that we put to the question and the database result. We ask the LLM for an answer. And now we need to parse it. Remember that I told you that we have a specific structure. So we need to parse it. And then we validate the final answer, and this is what we give back. Okay, so you may ask yourselves now, what about validation? And you're absolutely right. So where do we do validations? We do it in where we have the outputs of the LLM. So we have two outputs, when it generates the GraphQL query and when it generates the final answer. So how can we validate the GraphQL query? First, of course, we can check syntax. Remember, you as the developers, you're going to write the GraphQL schema, you're going to write the GraphQL resolver, so you know exactly what fields you allow to filter, you know the types of each field, you can very easily check if the syntax is correct. Second thing is that you just can run the query. Remember, with SQL, we were very afraid to run the query because it was directly on the database. But here, we're not afraid because if we run the query, what the query is going to meet is the resolver. So the worst thing that can happen is that we get error. But it's not going to damage our database. So with the error, we can handle. And how are we validating the final answer? So first of all, we decided that we're going to declare that the answer was generated by AI. This is very, very important. We want to train the doctors to get used, that they need to be very critical about the answers that they see, and they need to know it was generated by AI. Second, we decided that we always will give, along with the natural English answer, also the results from the database. So they can always compare and see, because the result of database is the real data. Okay? It's the real data, and we trust it. The answer from the LLM, this is where it can go wrong, right? So they can always compare. And we also use NLP tools to extract interesting entities, and we can always compare them to the database results that we have to make sure that there are no incorrect entities or values. That's it. What I would like you to take from this talk. First of all, embrace Gen AI. In Italiano si dice abbracciatelo. Because as you can see, it is possible and very beneficial to implement generative AI technology into the products that you would like to develop. It's true that LLMs may be unexpected and may generate, we don't know what they're going to generate, and they have a lot of uncertainty, and we cannot control them all the time, and we as developers and data scientists will have control. But here's the thing, with this uncertainty, this is where comes all the opportunities. So opportunity to develop tools that up to 1 year ago we couldn't even dream of. So with the right planning and with the deep understanding of who are your users, what are the requirements of your tool, what is the data and security limitations you have, with the LLMs, the sky is the limit. Thank you very much. It was really nice talking today.
Thank you very much. Unfortunately, we don't have time for questions, so you can ask Shirley afterwards.
You can approach me later for questions, no problem.
Thank you.
Thank you.